Hello there. Tonight we journey to the very beginning, to the edge of everything you've ever known and everything that will ever be. The air around you feels still, almost heavy with quiet expectation. You probably wouldn't notice it if you walked past the night sky on your way home, but every glimmer above you is a message from billions of years ago, traveling patiently through space to meet your eyes tonight. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And if you'd like, tell me where in the world you're listening from and what time it is there. Now, dim the lights and drift outward. You find yourself suspended in perfect silence. There is no up or down, no sound, no warmth. You are standing at the edge of the greatest story ever told, the story of everything. Around 13.8 billion years ago, the universe began not with an explosion, as we often imagine, but with expansion, space itself stretching out of a single, infinitesimal point. The moment time began, so did distance, temperature, and matter. In the beginning, there was no light, no galaxies, not even atoms. Only a dense, hot ocean of pure energy. You drift closer. You can almost feel it, a shimmering haze of particles so small and fast that they flicker in and out of existence. Scientists call this the quantum foam, the restless foundation of everything. For an instant, everything that will ever exist, stars, worlds, and you, was packed into something smaller than a grain of sand. Then, suddenly, expansion. Space unfolds, carrying energy with it, spreading faster than light itself. It's not an explosion in space. It's space growing, stretching like a living fabric. In less than a heartbeat, the universe swells from subatomic to astronomical. You might imagine it like a balloon inflating, but there's no air, no outside, only pure creation, expanding everywhere at once. The newborn cosmos glows with unimaginable heat, billions of degrees. So bright it would vaporize matter instantly. Particles collide, merge, annihilate. For the first few minutes, a delicate balance forms between creation and destruction. Protons and neutrons begin to dance, combining to form the first atomic nuclei: hydrogen, helium, a trace of lithium. Every breath you'll ever take, every star you'll ever see, begins here in this glowing sea of particles. And yet, despite its violence, there's something deeply tranquil about this beginning, like the heartbeat of a sleeping giant, steady and inevitable. Scientists still wonder whether the Big Bang was truly a beginning, or just the latest cycle in an eternal rhythm expansion following collapse, universe after universe, blooming like cosmic flowers. You move forward in time. The universe continues to cool. The dense light begins to thin, but photons, tiny particles of light, can't yet travel freely. They're constantly scattered by electrons. The cosmos is a fog of energy, radiant but opaque, like sunlight trapped in milk. But as you watch, expansion brings calm. The temperature drops to a few thousand degrees. Electrons finally find their partners, joining protons to make neutral atoms. The fog begins to clear. For the first time, light moves freely through space. That light, the first light, is still out there, stretched by time and distance, whispering across the universe. It fills every corner of the sky as a faint microwave hum, a soft afterglow of the beginning. If you close your eyes and listen, perhaps you can almost hear it, a steady sigh from the dawn of time. You drift further outward, and the scale begins to bend your imagination. In one direction lies the seed of every galaxy that will ever form. In another, the tiny quantum wrinkles that will one day become clusters of stars. It's as though you're floating inside the mind of the cosmos, watching thought itself take shape. The universe, once smaller than a marble, has now grown to the size of a solar system, and it keeps going, faster than light can chase it. Even now, billions of years later, that expansion hasn't stopped. Every second, galaxies move farther apart, carried by the stretching of space itself. The silence that surrounds you isn't emptiness, it's potential, a vast and patient waiting. There's a strange comfort here. Everything you've ever loved, every moment, every thought, all trace back to this quiet beginning. Out of chaos, order will emerge. Out of heat, light will be born. Out of stillness, motion. You begin to notice subtle patterns, tiny ripples of density, places where matter gathers just slightly more than elsewhere. These will become galaxies, though that lies far ahead in the story. For now, you're surrounded by the simple beauty of possibility. One curious fact: the universe isn't just expanding, it's cooling, slowing, stretching like a great breath drawn in. Right now, in your time, the average temperature of space is just 2.7 degrees above absolute zero, almost nothing. And yet, that faint warmth is the echo of this very moment you're witnessing. The past hasn't vanished. It's been stretched so thin it fills the air around you. You drift in the first darkness, where the seeds of everything have just been planted. Behind you, there's no before time itself began here. Ahead of you lies eternity, a vast unknown. And, as you hover, you sense that something magnificent is about to happen. The universe will soon give birth to structure, to ripples, to light, to the first glimmers of form. The silence deepens, and the temperature drops, like the air before dawn. You wait, weightless, in the calm between chaos and creation. Scientists still wonder whether this beginning required a cause, whether something beyond time set it into motion, or whether it simply is, infinite and self-contained. But as you float here, at the edge of understanding, the question feels less urgent. What matters is the feeling, the awe, of witnessing existence itself unfold from nothing. And so you drift on, further and further from that first instant, through expanding space, into the darkness that follows light. Somewhere ahead, the first stars will ignite. But for now, you simply breathe with the universe slow, even, and endless. You drift through darkness that isn't truly dark yet. It's a glowing kind of black, a deep, velvety haze, still humming with the energy of the Big Bang. Around you, the newborn universe has stretched itself vast and thin, a place where light has begun its long journey, and matter has started to settle into the faintest of patterns. At first, the cosmos feels perfectly smooth. The temperature, the energy, the density, nearly identical everywhere. But if you could touch the early universe, you'd feel a subtle texture beneath your fingertips, tiny ripples, barely noticeable. These are the quantum fluctuations, microscopic tremors in space-time itself, born from the restless uncertainty that rules the subatomic world. In this moment, the entire future depends on them. You drift closer, peering at a region no bigger than a grain of sand. Within it, the balance is slightly uneven, an extra handful of particles here, a few fewer there. Those small differences will grow with time, expanding as the universe expands. They will become galaxies, clusters, and eventually entire cosmic continents of matter and light. Without these ripples, the universe would remain an endless fog, structureless, silent, forever smooth. The most mainstream fact is that these primordial fluctuations left fingerprints we can still see today, frozen into the cosmic microwave background. Scientists have mapped them tiny temperature variations, no greater than 1 part in 100,000. To the eye, the sky looks uniform, but in those minute patterns lie the seeds of every star, planet, and heartbeat that ever existed. As you watch, the ripples move like soft breaths through a vast ocean. Gravity begins its quiet work. Where the density is slightly higher, matter tugs gently inward. It's as if the universe is learning how to organize itself. Invisible scaffolding starts to form, stretching across unimaginable distances. These early whispers of order mark the first promise of what will one day be galaxies. The expansion continues relentlessly. What once was hot and crowded is now spacious, cool, and calm. You can feel the silence deepen around you. There's no sound. Sound can't travel through a vacuum, but there's rhythm. The rhythm of gravity pulling, expansion pushing, the dance that will shape all of space and time. You drift among currents of invisible energy, each fluctuation swelling into something grander. Some regions slow down, thickening with matter, others thin and empty. If you could look far ahead, you'd see these places becoming the filaments and voids of the cosmic web. But here and now, it's like watching the first ripples on a calm pond spread outward into infinity. A curious, quirky fact emerges. These fluctuations weren't random noise, they were quantum effects magnified to cosmic scale. What happens in the smallest realm of physics, the domain of probability and uncertainty, has determined the shape of everything, vast and grand. It's as though a butterfly of pure energy once fluttered in the quantum foam, and its wings became the spirals of galaxies. Scientists still wonder whether these quantum tremors were a product of inflation, an early supercharged expansion that stretched the fabric of space faster than light, or if they came from something even deeper, perhaps the fingerprints of other universes brushing against ours. The debate continues, softly, like an echo of those ancient ripples. You drift farther, the light growing fainter. There are no stars yet, no warmth from burning suns, only the cold glow of radiation left from the beginning. It's everywhere, the same in every direction, an endless twilight of microwaves. If you could see it with your eyes, it would be a gentle orange haze surrounding you, the first true sky of the cosmos. You notice how peaceful it feels here. The universe has expanded enough that its wild youth has quieted. Temperatures have fallen to just a few thousand degrees, still hotter than the surface of a star, but cooling rapidly. You can almost imagine the hiss of thermal energy fading away. Everywhere, atoms are forming, hydrogen, helium, and traces of lithium. Simple, elegant building blocks drifting freely through the void. They will become the material of stars, planets, and life itself. But for now, they're content to float, tiny, neutral, unbound, waiting. You move with them, following a soft current through a region slightly denser than its surroundings. The density will grow, slowly. Over millions of years, gravity will pull these particles together, gathering them into clouds. Those clouds will collapse into stars, igniting the first light that will pierce this darkness. You are floating in the womb of the first galaxies, though they don't yet exist. You begin to sense the scale of what's to come. The distances between atoms stretch beyond comprehension, trillions of kilometers of emptiness between tiny points of matter. It's the same pattern that will persist forever. Immense distance, separating luminous islands. Space is learning its rhythm of vastness. A faint pulse of time passes. A few 100,000 years. Then, 1,000,000. Then, 10 million. Gravity's patience is absolute. It never hurries. The ripples continue to grow, gathering momentum. Soon, they will give rise to clouds, so immense they dwarf imagination. Clouds that will ignite, fusing hydrogen into light. But for now, you drift through the calm before the first dawn. The universe hums softly with its background radiation, a whisper from its own birth. If you close your eyes, you can almost hear the silence between the ripples, the peace between creation's notes. A passing thought. These patterns, delicate and ancient, resemble the ones found in your own world, in clouds, in oceans, in the patterns of your heartbeat. The universe, it seems, repeats itself in every scale, from the quantum to the cosmic. Scientists still wonder whether those first fluctuations were truly random or guided by hidden laws deeper than physics itself. Perhaps some symmetry of reality not yet discovered. It's a question that drifts unanswered, like starlight yet to be born. The silence stretches again, long and luminous. You feel time slow, almost stop, as if the universe is taking a breath before its next transformation. The ripples fade into a gentle calm, and you sense that somewhere in this vastness, the first sparks of light are beginning to form, though you cannot yet see them. For now, you float quietly in the dark, surrounded by potential. Embraced by cosmic stillness, the universe rests, preparing for its first awakening. You move through the cooling cosmos, and at first, it feels as though nothing is changing. The light that once filled all of space has thinned to a faint, invisible glow. But somewhere, in the stillness, something subtle is happening. The fog of the early universe is clearing. Photons, particles of light, are slipping free for the first time. You can almost see it, a veil lifting, a haze dissolving. The universe is becoming transparent. For nearly 400,000 years, the cosmos has been too dense, too hot for light to travel. Every time a photon tried to move, it collided with an electron, scattering endlessly. It was like trying to see through boiling water. But now, as space stretches and cools, the electrons are finally calming, finding protons to embrace. They form hydrogen atoms, simple, stable, and transparent. Suddenly, the light escapes. That light still travels today, across 13.8 billion years of expansion. It's what scientists call the cosmic microwave background, the oldest light in the universe. If your eyes could see microwaves, the night sky would glow softly in every direction, a perfect, gentle radiance from the birth of transparency itself. You drift through that first light now. It's faint, a soft golden haze fading slowly to red as the universe expands. This is the afterglow of creation, a moment of calm clarity after a storm of unimaginable heat. The cosmos has entered its long, slow dawn. The mainstream fact here is simple yet profound. This faint light, this ancient radiation, carries a perfect record of the universe's early state. It's a cosmic photograph, capturing the precise moment matter and light parted ways. Astronomers have studied it in exquisite detail, finding in its patterns the story of everything that followed the birth of galaxies, the shape of space itself, even clues about the universe's ultimate fate. But for now, it's just beautiful. The fog has lifted. Space is clear. For the first time, light travels freely across the cosmic sea. You glide gently through this newborn clarity, surrounded by silence and color. Hydrogen atoms float like invisible snow, scattered across infinite darkness. The temperature has fallen to a few thousand degrees, still warm enough to glow faintly red, but fading with every passing moment. Here, in this early calm, you feel the first sense of peace in the universe's story. Everything before this was chaos, collisions, radiation, fire. Now, there is quiet. Space itself hums softly with the memory of creation. A quirky, almost poetic fact. If you could tune an old television to static between channels, about 1% of that faint hiss would come from this very light, the cosmic background echoing through your living room. You've been hearing the birth of the universe all along, without even realizing it. Scientists still wonder whether the universe's early clarity holds hidden messages, patterns too subtle for us to yet decipher. Some theories suggest that the faint variations in the cosmic background could hint at neighboring universes or at physics deeper than we understand. In its gentle noise might lie clues to the multiverse or to the strange quantum nature of space-time itself. You drift onward, through an era known as the Cosmic Dark Ages. The light fades further, stretched to longer wavelengths by the continuing expansion. The stars have not yet been born, and galaxies are still gathering from cold hydrogen clouds. The universe is vast and utterly dark to human eyes, but not empty. Everywhere, gravity is patiently working, shaping clouds of gas into denser knots. You pass one such region, an invisible swell of hydrogen and helium. It's enormous, spanning light years, yet delicate as breath. Gravity tugs at it, imperceptibly slow, pulling gas inward. The process will take hundreds of millions of years, but eventually, this region will ignite. It'll become the first star, burning hydrogen into light once again. You might expect such beginnings to be violent, but here in the dark, everything moves in slow motion. Collisions are rare, heat builds gently. The silence is profound. It's the kind of silence that feels alive, a pause before the universe exhales. The atoms drifting past you are simple, but in their simplicity lies everything. Hydrogen, one proton, and one electron will become the fuel of stars, the source of all energy, and the root of all chemistry. Helium, stable and serene, will fill the cores of suns. These quiet elements, floating invisibly now, are the alphabet of creation. You feel a strange kinship with them. After all, the atoms in your own body trace their lineage back to these same particles. The hydrogen in your blood, the helium that once pulsed through a star's heart, they were all here, in this calm young universe, waiting. You notice, too, how expansion changes your sense of time. Distances stretch, light fades, and moments seem longer, slower, like the deep breaths before sleep. What feels like seconds to you might be millions of years to the cosmos. The rhythm of creation is gentle, deliberate, unhurried. Everywhere you look, the light continues to fade. The once brilliant universe has cooled to just a few dozen degrees above absolute zero in your perspective, its warmth lost to distance and time. But that faint afterglow remains a soft, steady whisper of light across the sky. It's remarkable to think that this faint radiation, this quiet remnant, once blazed with the intensity of a star. Over billions of years, the stretching of space has cooled it, dimmed it, softened it, until it became the perfect lullaby of the universe. You drift on, feeling smaller but more connected than ever. The light touches you, delicate as silk. It carries the fingerprint of everything that came before the heat of creation, the rhythm of expansion, the structure of space itself. It's the universe's memory, still glowing after all this time. Scientists still wonder if the universe's first light truly marked the end of its chaos, or merely the beginning of a new kind. Some believe this clarity is when dark matter began to dominate, quietly shaping the large-scale architecture of everything to come. Others think it might have been when dark energy began its long, subtle influence, the whisper that will one day stretch the cosmos beyond recognition. But for now, you let the light wash over you. The fog has cleared, the first dawn has passed, and the universe is resting in its long twilight. Soon, gravity will kindle the stars, and the darkness will glow again. You drift weightlessly, carried by the calm breath of a universe newly at peace. The silence deepens, and you find yourself surrounded by light, so faint it feels like memory. You close your eyes and listen not to sound, but to the steady hum of existence itself. You glide farther into the unfolding universe, and though your eyes see only darkness, there is movement everywhere. The universe is expanding, its very fabric stretching in all directions at once. It's not space expanding into something, it's space itself growing, every point drifting away from every other. You feel it in your chest, a slow, continuous pull, like a deep cosmic breath being drawn forever outward. The expansion began in the first fraction of a second, but its echo still shapes everything. Imagine painting dots on the surface of a balloon. When the balloon inflates, the dots don't move through space. The space between them grows. That's what's happening all around you, on a scale so vast that galaxies themselves will one day be swept apart by it. Right now, there are no galaxies yet, just cold hydrogen and helium filling the universe like invisible mist. But already, expansion has slowed enough for gravity to start weaving its quiet patterns. Tiny regions of slightly greater density tug matter inward. They grow heavier, denser, and their gravity pulls in more. Slowly, softly, the seeds of structure begin to take hold. The mainstream scientific fact here is both simple and staggering. The universe isn't just in motion, it is motion. Every bit of space stretches continuously, even between your atoms. You don't feel it because the forces binding you are strong, but across intergalactic distances, expansion rules all. You drift between those early ripples, watching the cosmic fabric lengthen. The darkness feels almost fluid, smooth as glass. You realize there's no center, no edge, no direction that leads out. The universe is all there is, an expanding whole, infinite in every direction you can imagine. Yet something curious happens as it expands. The more it grows, the colder it becomes. Energy spreads thinner. The wavelengths of light stretch longer, fading from visible to infrared to microwave. The first light you saw in the last section, the afterglow of the Big Bang, continues to dim, redshifted by time itself. It's like watching an ancient fire cool into embers. Scientists call this cosmological redshift. As space expands, light waves stretch along with it. A photon traveling across the cosmos loses energy, not because of friction or resistance, but simply because the distance it must cross is growing beneath it. It's a quiet, elegant effect, the universe's way of whispering its age. You drift deeper into this soft, cooling void. There's a strange beauty in the simplicity of it all. Hydrogen atoms float like lonely travelers, bound by nothing. They move at random, colliding now and then, forming clouds so faint they would seem invisible, even to a god's eye. And yet, the seeds of grandeur are hidden in this calm. Gravity never sleeps. Wherever matter gathers just slightly more densely, it begins to draw more to itself. Those regions grow, thickening slowly, invisibly, until one day they'll collapse into the first stars. For now, you're in the long, patient era of expansion and waiting. The temperature has fallen to just a few dozen degrees above absolute zero. The light of the cosmic background has faded to a dull microwave hum. Space is vast and eerily still, like the pause between two heartbeats. You feel weightless, timeless. Each moment stretches farther than the last. A quirky fact, even now, billions of years later, the universe's expansion continues, and not only continues, but accelerates. Distant galaxies are speeding away faster and faster, carried by a mysterious pressure known as dark energy. But in this ancient time you're floating through, that force is still faint, almost asleep, while gravity holds sway. The future acceleration will come much later. Scientists still wonder whether space itself has boundaries, whether expansion means it will one day tear apart everything, or whether unseen dimensions curve it back onto itself. The question lingers, like a soft echo in the dark. Some think the universe might wrap around, meaning, if you traveled far enough in one direction, you'd eventually return from the other side. Others believe it's infinite, stretching endlessly beyond comprehension. You float, gazing at nothing, and yet, in that nothing, there's motion everywhere. It's like standing in still air that you somehow feel is flowing. Every second, every particle, every distant region is moving apart from every other. Even though you can't see it, you sense expansion happening quietly beneath all things, the hidden rhythm of the cosmos. If you could visualize it, space would look like an intricate three-dimensional fabric, stretching uniformly. Galaxies, when they finally exist, will move with this fabric, not through it. You realize, almost with awe, that expansion isn't the movement of things in space, it's the growth of space itself. And you are within it. You are part of that stretching, part of the rhythm of an infinite fabric breathing out across time. You drift near a region where density is just a little higher. A faint gravity tugs at you, almost imperceptible, like the sensation of being called home. Around you, wisps of hydrogen begin to swirl, moving inward. The darkness gains a hint of structure, filaments forming, like veins beneath translucent skin. These are the first outlines of the cosmic web, faint and ghostly. If you could hear the process, it would sound like a low hum, an almost musical vibration as gravity draws matter together. The universe has begun to compose itself. And as you move farther, you notice the distances between dense regions expanding too. Expansion and gravity are in a constant tug of war, one stretching space outward, the other gathering matter inward. For billions of years, this balance will sculpt everything you'll one day see in the night sky. Scientists still wonder what exactly controls this cosmic balance. They understand how gravity behaves, and they can measure expansion's acceleration, but they don't yet know why dark energy exists, or even what it truly is. It's one of the greatest mysteries of modern cosmology, an invisible force woven into the universe's very equations. You continue to drift through the stretching dark, surrounded by the hum of distant radiation. Space feels vast beyond imagination, but also oddly intimate, as though it's expanding just for you. You breathe in, and it's as if the universe breathes with you. Expansion is not destruction, it's creation. It's the making of space, the unfolding of room for stars, for life, for thought. Without it, everything would remain compressed and still. The growing universe gives time its meaning, distance its depth, and existence its quiet rhythm. You glide onward, and the darkness begins to deepen. Somewhere ahead, gravity's patient work will ignite the first stars. Their light will pierce this endless night, scattering color and warmth across the void. But for now, you linger in the great breath of expansion, the calm, unending swell of the universe, as it continues to unfurl its infinite canvas. You drift through the growing expanse, and slowly, imperceptibly, the dark begins to change. What was once uniform, smooth as ink, now shimmers with the faintest suggestion of texture. Matter has gathered into delicate filaments, invisible to the eye but woven across billions of light years. You are floating through the quiet lattice that will one day cradle galaxies. Gravity has been working patiently, drawing atoms together, sculpting shapes out of emptiness. In some regions, clouds of hydrogen have become so dense they begin to collapse under their own weight. The temperature inside those clouds rises, friction building as particles collide, transforming motion into heat. And then, after hundreds of millions of years of silence, something wondrous happens. Light returns. You watch as the first stars ignite, brilliant, enormous, and brief. They burn with blue-white intensity, far hotter and larger than the stars you know. Each one is 1,000 times the size of your sun, but it will live only a few million years before collapsing in fire. These first stars, population 3 stars, as scientists call them, are the universe's first furnaces. Inside them, hydrogen fuses into helium, releasing floods of radiation that sweep across the cosmos. You feel the warmth of those newborn lights washing over the cold, ancient dark. It's the universe's second dawn. The mainstream scientific fact is simple but astonishing. Everything heavier than hydrogen or helium, every atom of oxygen you breathe, every carbon molecule in your body, Every speck of gold or iron on your planet was created in the hearts of stars like these. When they die, they explode, scattering their ashes across space, seeding the next generation of stars with new elements. You, quite literally, are made of stardust. The stars gather into clusters, and those clusters begin to swirl together, drawn by mutual gravity. Slowly, the first galaxies form immense whirlpools of light, surrounded by the invisible halo of dark matter. From afar, they look like faint, spinning clouds. Some are small, just a few thousand light-years wide. Others already span hundreds of thousands. Each glows softly with the light of countless stars. You float closer to one of them, a fragile spiral forming from chaos. Streams of glowing gas weave through its arms, tracing the gravitational ballet of birth and motion. You can sense the weight of it. Trillions of stars, yet moving in silence, the hum of their collective energy filling space like a deep, steady tone. A quirky fact: galaxies are mostly empty. If you stood on one star's surface and looked toward its nearest neighbor, the distance would be so great that it would take light years to cross the gap. Even inside the densest galaxy, space is mostly nothing. The beauty of galaxies isn't their fullness, it's their balance between light and void, order and emptiness. Scientists still wonder how exactly these colossal structures emerged so quickly. The first galaxies appear surprisingly early in the cosmic timeline, just a few 100 million years after the Big Bang. That may not sound fast, but on the scale of cosmic evolution, it's a blink. Some astronomers believe dark matter guided the process, forming invisible gravitational wells that pulled gas together. Others think early star clusters merged and merged again, slowly building the luminous giants we see today. You drift among these newborn galaxies, each one unique. Some are irregular, messy, still colliding with their neighbors. Others have already begun to spin, forming elegant spirals like cosmic seashells. Their light is pale and pure, untainted by dust. If you could hear it, it might sound like a chorus of distant singing bowls, each tone distinct, yet blending into harmony. The space between galaxies grows too, stretched by the ongoing expansion. You realize that as the universe grows, it's not the galaxies themselves that move apart, it's the space between them that swells, like ink spreading through water. Even now, billions of years later, that expansion continues. You, your world, your galaxy, all are passengers on this endless outward current. Inside the galaxies, creation continues. New stars ignite, old ones die. Supernovae, massive stellar explosions, scatter heavy elements through the surrounding gas, enriching it. Each burst of light becomes a spark for new life, a recycling of cosmic material. In time, planets will form from these ashes, worlds of rock, ice, and ocean, each orbiting its parent star in silent circles. You drift past a nebula, a glowing cloud of gas and dust, illuminated by a nearby star. It glows pink and violet, the color of hydrogen under ultraviolet light. Tendrils twist like smoke, delicate as silk. Within those folds, gravity works again, shaping new stars from the leftovers of the old. The universe has begun its great cycle: birth, death, and rebirth. A curious observation arises. Even though galaxies are vast, they behave like living things. They grow, merge, and evolve. Some spiral into graceful forms, others collide, forming massive ellipticals. They even seem to have lifespans. Young galaxies bright and blue with new stars, older ones dim and red as star formation fades. Scientists still wonder whether galaxies shape the universe, or the universe shapes galaxies. Does structure emerge from within, or does it flow from the invisible hand of dark matter? It's an open question, whispered through telescopes and supercomputers alike. As you drift farther, you see thousands, then millions of galaxies. They cluster into filaments, vast strings spanning the cosmos. Between them lie enormous voids, regions so empty they seem like holes in reality. The scale defies comprehension. If your mind could stretch far enough to hold it all at once, you might feel the faint tug of infinity itself. You pause, floating in the soft glow of starlight, scattered across eons. It's peaceful here, and strangely familiar. The rhythm of creation feels organic, almost human. You realize that the stars, the galaxies, and you share the same origin, built from the same atoms, following the same laws of motion and change. The light of distant galaxies reaches you like echoes through deep water, dimmed and softened by distance. Some of that light began its journey long before your planet existed. It travels still, carrying with it the memory of a time when the cosmos was young and full of promise. You close your eyes and let it wash over you. Somewhere, far ahead, galaxies will continue to grow, to collide, to evolve. But for now, you linger here among these first cosmic islands, adrift in a sea of stars. The expansion continues. The universe breathes out. The galaxies drift apart, each one a glowing ember in the endless dark. You are surrounded by the quiet rhythm of creation, and it feels for a moment like the heartbeat of eternity itself. You glide through a spiral arm of one of those newborn galaxies, its glowing dust clouds curling around you like ribbons of smoke. The light is soft, golden, scattered by grains of carbon and silicate. Each glimmer you see is a sun, countless stars, arranged in elegant patterns, all turning slowly around a dark, unseen center. The movement is so gradual it feels almost still, but if you watch long enough, you sense the entire galaxy breathing in slow motion. Here, stars live quiet, patient lives. Their stories begin in the cold embrace of nebulae, vast clouds, where gas collapses under gravity until fusion ignites. You pass near one such nursery now, a cradle of creation. The airless silence is filled with invisible radiation, a soft glow that hums in wavelengths beyond sight. Inside the densest regions, the gas begins to shimmer. Protostars' tiny bright knots are being born. You drift closer to one, a glowing sphere still wrapped in a cocoon of dust. Its surface boils with convection, turbulent streams of heat rising and falling. Deep inside, hydrogen atoms fuse into helium, releasing energy that struggles to escape. That energy will shine as starlight for billions of years. The mainstream scientific fact is this: every star you see balances two opposing forces, gravity pulling inward, fusion pushing outward. This perfect equilibrium allows a star to burn steadily, like a candle with an eternal flame. When that balance fails, stars transform dramatically, some collapsing, others exploding, scattering their elements across the galaxy. For now, though, the star before you is calm. Its light falls gently across the surrounding dust, turning it to gold. The particles shimmer like drifting pollen. You feel as though you're floating inside the breath of creation itself. In time, planets will form from this dust, tiny clumps that collide, merge, and grow. It's a slow process, billions of years in the making. You imagine it happening in silence, the faint tap of rocks meeting, the whisper of dust settling into orbits. Somewhere, in one of these future systems, there will be a small blue world, but that lies far ahead. You pass into a region filled with mature stars, each one a distinct shade of white, blue, or amber. Their light bathes the galaxy in color, subtle and beautiful. Some burn fast and bright, massive stars that will live brief, intense lives. Others, like red dwarfs, glow faintly for trillions of years, their warmth steady and patient. A quirky fact: if you were to hover near a red dwarf, its light would seem dim, but its heat would be comforting, a deep, infrared warmth invisible to the human eye. Most of the stars in the universe are red dwarfs. The night sky, you know, is an illusion of brightness. The cosmos is truly ruled by faint, quiet suns. You glide toward one of the larger stars, a blue giant. It radiates fierce light and fierce energy. Its surface is alive with storms, currents of plasma swirling faster than any hurricane on Earth. The heat here is intense, enough to vaporize matter in an instant, but there's a kind of grace in the chaos. The star pulses subtly, expanding and contracting, as if breathing in time with the cosmos itself. Stars, like all things, are temporary. The blue giant you watch will one day run out of fuel. When that happens, gravity will win. The core will collapse in a heartbeat, igniting a cataclysmic explosion, a supernova. That blast will be powerful enough to outshine entire galaxies for a moment. It will also create new elements: iron, nickel, even gold. You might wear a fragment of such a moment on your finger, or feel its warmth in your bloodstream. You pause for a while, watching the light from countless stars mingle. It forms a kind of cosmic lullaby, steady, serene, infinitely slow. The galaxy turns, and with it, the endless dance of birth and death continues. Scientists still wonder whether every star follows the same pattern, or if the universe holds exceptions, objects that defy the balance between fusion and gravity. Some suspect there may be stars so massive they collapse into black holes without ever exploding, vanishing silently into their own gravity wells. Others search for dark stars, hypothetical objects that might shine not by fusion, but by the annihilation of dark matter within. The debate drifts quietly among telescopes and equations, unanswered for now. You travel onward through the galaxy's arm, past regions thick with starlight, and others empty as thought. Between the bright clusters lie enormous voids, deserts of gas and dust, where few stars exist. The contrast feels poetic, bursts of brilliance surrounded by stillness. The cosmos seems to know that beauty requires both light and dark. Everywhere you look, stars shimmer in different stages of life. Some are infants, wrapped in gas clouds. Others are aging giants, swelling to hundreds of times their original size. You watch one such star, a red supergiant nearing its end. Its outer layers billow outward, shimmering with orange and crimson light. You can almost hear the faint, slow rhythm of its expansion, a sigh stretched across millennia. When it dies, it will scatter its outer layers into space, forming a glowing nebula, a cosmic flower blooming one last time. The core that remains will shrink into a white dwarf, no larger than Earth but with the mass of a sundae. Over billions of years, it will fade, cooling slowly until it becomes invisible, a black dwarf in the endless night. The galaxy's spiral arms carry these stories like threads, weaving them into a tapestry of energy and change. You drift with them, feeling time slip away. Millions of years pass in the space of a breath. The starlight around you is constant, yet every glimmer represents something transient. Even the most enduring suns will one day fade. And yet, there's peace in that impermanence. The stars are not lost. They become the ingredients for new stars, new worlds, new possibilities. The universe recycles itself endlessly, never wasting, always transforming. You feel the warmth of 1,000 suns brushing your skin, not heat, but memory. Each photon that touches you has traveled across unimaginable distances. Some were born before your world existed. Some will continue long after your species is gone. You are part of that journey, a fleeting thought in an eternal rhythm. You close your eyes. The galaxy spins gently around you, its light painting soft trails through the void. The hum of fusion continues, constant and soothing, like the sound of deep water. Somewhere, unseen, the next transformation waits to begin. You drift onward through the galaxy's quiet heart, where light bends and time itself slows. Somewhere ahead, one of those massive stars you saw before, perhaps a blue giant, Perhaps something even larger has reached its end. Its light flickers, then fades, replaced by a strange, expectant stillness. You move closer, and you feel it before you see it. A pull, subtle at first, then growing stronger, like the tide of gravity itself calling you home. The star collapses inward. In less than a second, its outer layers fall toward the core, crashing at a fraction of light speed. Matter compresses so tightly that atoms break apart, electrons and protons fusing into neutrons. The explosion that follows a supernova flares with unimaginable power. For a brief time, it outshines the rest of its galaxy combined. Shockwaves ripple outward, scattering stardust, creating new clouds of gas and elements. But at the center of the blast, something extraordinary remains. A singularity. A black hole. It is small, almost invisible, but impossibly dense. All the mass of a massive star collapsed into a single point, so heavy that space curves inward upon itself, trapping even light. Around it, gravity becomes absolute. The boundary, where nothing can escape, is called the event horizon. Beyond that, no message, no signal, no photon can return. The mainstream scientific fact is astonishing. Black holes are not holes in space, but regions of extreme curvature, where the geometry of reality folds so steeply that all paths lead inward. They do not pull you like magnets. They reshape the fabric of existence itself. You hover near one now, watching from a safe distance. Around the event horizon, matter spirals inward, forming an accretion disk, a whirlpool of plasma heated to millions of degrees. The light is fierce and blue, bending around the black hole, distorted by its gravity. Time slows as you approach. Seconds stretch into minutes, minutes into years. From your perspective, the world beyond races ahead, while here, near the edge, everything holds its breath. You can almost hear it, the faint hum of warped space-time, the quiet vibration of gravity itself. A quirky fact: if you could shrink the Earth to the density of a black hole, it would be less than 2 centimeters wide, a marble of infinite gravity. Yet, paradoxically, black holes themselves can be incredibly large. Some, at the centers of galaxies, weigh billions of times more than the Sunday. And the one you're drifting near now? It's one of the first of its kind, born from the death of a massive primordial star. It will one day merge with others, growing larger with each union. You move closer, drawn not by motion, but by curiosity. The edge of the event horizon shimmers, light bending around it in a perfect circle called the photon sphere. It's the ultimate mirror, every beam of light orbiting endlessly, never escaping, never quite falling in. You see reflections of distant stars wrapped around you in every direction, their images stretched and multiplied. The view is dizzying, beautiful, infinite. Scientists still wonder what happens beyond the event horizon. The laws of physics, so reliable everywhere else, break down inside. Does the matter vanish into a point? Does it form a new universe, hidden from ours? Does information patterns of reality survive, encoded somehow in the surface of the horizon? The debate is one of the deepest mysteries of science, a question that might never find a certain answer. You float there, watching the interplay of gravity and light. The black hole is silent, but its surroundings roar with energy. As matter falls in, it releases radiation in X-rays and gamma rays, brief flashes that travel across galaxies. Some of those photons will reach distant worlds billions of years from now, faint whispers of this very moment. You feel the paradox of it. Black holes destroy and create at once. Their gravity tears matter apart, but in doing so, they shape galaxies, regulate star formation, and feed the engines of quasars, the brightest beacons in the universe. The death of one star becomes the heartbeat of a cosmos. You drift a little farther back, watching the surrounding space calm again. The supernova's remnants spread outward, gas and dust glowing in a sphere of color. Inside the expanding shell, the black hole remains hidden, silent, unseen. Around it, new stars will one day form from the scattered debris, continuing the endless cycle. A faint thread of light crosses your vision, a distant jet of plasma, streaming from another black hole nearby. These jets can travel millions of light years, narrow as the width of a thought, yet longer than entire galaxies. They are powered by the twisting of magnetic fields in the spinning disk of material around the hole. You trace the line of light as it fades into the void, elegant and infinite. You pause to consider the scale. A black hole is smaller than a star, yet it can govern an entire galaxy's rhythm. At the center of almost every large galaxy, including your own Milky Way, sits a supermassive black hole. It holds millions of suns worth of mass and anchors the motion of every star that orbits within. In a way, each galaxy has a dark heart, a silent conductor guiding its cosmic symphony. You glide away, the black hole shrinking to a small distortion in the distance. The stars ahead shimmer through faint ripples of space-time, each beam of light slightly curved by the gravity you've just passed through. The effect is subtle, like looking through glass that's just barely uneven, but it's enough to remind you that nothing travels through the universe untouched. Every particle, every photon, every life is shaped by gravity's hand. Scientists still wonder whether black holes are the final form of matter, or whether, over inconceivably long times, they too will fade away. Stephen Hawking once proposed that black holes emit faint radiation, losing energy slowly until they vanish. If that's true, then even these titans of gravity are temporary, destined to evaporate into nothing. The thought brings a strange kind of peace. Nothing lasts forever, not even the universe's darkest hearts. Everything transforms, recycles, begins again. You float in the faint afterglow of the supernova's remnants, the light spreading softly through the void. The explosion's energy, the black hole's silence, the star's steady glow, all merge into one vast harmony. You listen to it, a soundless hum that feels like time itself breathing. Ahead, gravity's echoes ripple outward. Space bends, light curves, and somewhere in the distance, another collapse begins. The cycle continues. Endings, feeding beginnings, silence, birthing sound. You drift onward, weightless, through the twilight between destruction and creation. You follow the faint vibrations left behind by that collapse, those invisible waves of gravity rippling through space itself. They travel not through air or matter, but through the very fabric of reality, stretches and squeezes so slight that even the most sensitive instruments barely detect them. Yet they are everywhere, passing through galaxies, through worlds, through you. You drift in their path, feeling the subtle pulse of space-time under you. It's as though the universe is breathing again, its rhythm spread across billions of light years. Every merger, every collision, every collapse leaves a trace, tiny echoes of power that never fade entirely. The mainstream scientific fact, gravitational waves are distortions in space-time caused by massive, accelerating objects, black holes colliding, neutron stars spiraling together, entire galaxies dancing in gravity's embrace. First predicted by Einstein in 1916, they were finally detected a century later, in 2015, by the LIGO Observatory on Earth. The detection confirmed one of the last untested predictions of general relativity and opened a new way of listening to the cosmos. You float in this strange silence, where the only sound is space-time itself flexing. The waves aren't like ordinary ripples in water. They stretch everything as they pass, expanding and contracting the distance between points. If you could see them, the universe around you would shimmer rhythmically, stars moving closer and farther apart by fractions of an atom. You drift past one particularly powerful source, a pair of black holes locked in orbit. They circle each other in a spiraling dance, losing energy as they emit gravitational waves. With every turn, they draw nearer, their orbits shrinking, the frequency of their waves rising. You can almost hear it, a deep, bass-like hum rising to a soft, ringing tone. Then, suddenly, silence. The two black holes merge, becoming one. You feel the ripple pass through you, gentle but vast. Space stretches, then relaxes again. The echo of that union travels outward forever, carrying the signature of that moment to the edge of time. A quirky fact: when LIGO first detected gravitational waves, the signal came from two black holes, merging over 1 billion light-years away. The entire event lasted less than a second, but the energy released in that instant was greater than that of all the stars in the observable universe combined. And yet, the wave that reached Earth moved the detectors by less than the width of a proton. Power beyond imagination, measured in whispers. You glide alongside another ripple, one born of a different collision, a pair of neutron stars. These are the collapsed cores of massive stars, each only about 20 kilometers wide but heavier than the Sunday. When they collide, their crash releases both gravitational waves and light, allowing astronomers to watch the universe in two ways at once, by sight and by gravity's touch. You see it unfold before you, two tiny spinning spheres, orbiting faster and faster. Their magnetic fields twist into knots. Then, in an instant, they merge. The explosion flares gold and blue, scattering heavy elements into the void. Gold itself real. Physical gold is born in that moment, along with platinum and uranium. Every ring, every coin, every trace of gold on Earth began in a collision like this. You pause, watching the expanding cloud of light. Its edges glow faintly violet as it cools. The ripples continue outward, fading into the deep. You realize that even now, in your own time, Earth is being touched by countless such waves, gravitational murmurs from distant cataclysms, washing over you every second without your notice. Scientists still wonder how many of these events happen in the cosmos each year. The universe is vast enough that somewhere, at every moment, black holes collide, neutron stars merge, galaxies brush together. The sky above you may look serene, but beneath its calm, space is trembling with energy. You drift farther, through a region where these ripples overlap, creating interference patterns in space-time itself. It's like standing in a shallow sea at night, where overlapping waves form shifting patterns of motion. Here, gravity behaves almost like sound, its waves blending, resonating, amplifying each other in places. The effect is mesmerizing. For a moment, you close your eyes and imagine these gravitational waves as music, an endless, low symphony played by the cosmos. Each note corresponds to a mass moving, each chord to a collision. If you could translate the data LIGO records into sound, you'd hear a faint chirp, rising tones marking the final moments before a merger. The universe has been singing this song since its birth, but only recently have we learned to listen. The waves fade, and you find yourself drifting through a calmer part of space. The background hum becomes faint again. Around you, distant galaxies glitter, their light rippling subtly as the fabric of space-time flexes beneath it. The stars no longer seem fixed. They shimmer, ever so slightly, like reflections in water. A curious fact strikes you. Even light from the earliest galaxies carries traces of these distortions. Each photon's path bends slightly as it passes through ripples and warps, arriving to you just a bit out of rhythm. The night sky is not a static image. It's a living record of a universe forever in motion. Scientists still wonder what gravitational waves can truly reveal. Perhaps they'll uncover signs of events from the very beginning, the birth of the universe itself. Some theories suggest that tiny, ancient ripples from the Big Bang are still moving through space, waiting to be detected. If we could capture them, we'd be listening directly to the echo of creation. You float quietly now, imagining those ancient tremors, the first vibrations of space-time as it came into being. They would be faint beyond measure, weaker than any sound, but still real waves from a time before stars, before light. You open your senses to the cosmic silence. Somewhere behind that silence, there is motion, endless and serene. Every heartbeat of the universe leaves a trace. Every movement becomes part of the infinite pattern. The ripples never truly stop. They fade, merge, and begin again, like breathing. You let the rhythm carry you, gentle and steady. The universe feels alive, not as a thing of matter and energy, but as a living fabric stretching, vibrating, remembering. You drift, weightless, a listener floating in the music of space and time. You drift deeper into the dark, leaving behind the trembling echoes of gravity's song. Ahead of you, the universe grows vast again, so vast that even the light from 1 billion stars can't fill the emptiness. Yet, you sense something unseen here, something that shapes everything without ever revealing itself. It's not light, not gas, not the stars themselves, but something more subtle, something silent. It is dark matter. You move through it without feeling resistance. It doesn't glow, doesn't scatter light, doesn't interact with ordinary matter, except through gravity. Yet it is everywhere, an invisible scaffolding that holds galaxies in place. Without it, the universe as you know it would never have formed. The mainstream scientific fact: dark matter makes up about 85% of all matter in the cosmos. All the planets, stars, and dust you can see are just a tiny fraction, the glowing frost on an unseen glacier of mass. Galaxies spin the way they do because of dark matter's gravity. Without it, their stars would scatter into space like sparks from a dying fire. You drift toward a spiral galaxy and watch it turn. The outer stars whirl around its center faster than they should, as if something hidden is holding them in orbit. That something is the halo of dark matter, a vast, spherical cloud surrounding the galaxy, unseen but essential. You can't see it, but you feel it in the motion, in the balance, in the grace of every orbit. A quirky fact: if you could see dark matter, the night sky would look utterly different. The Milky Way would glow with immense, ghostly arms, its dark halo stretching far beyond the visible stars. It would look like a vast jellyfish of light and shadow, its tendrils reaching into the cosmic deep. Scientists still wonder what dark matter truly is. Some think it might be made of undiscovered particles, weakly interacting massive particles, or WIMPs, ghost-like entities that pass through everything. Others suspect something more exotic: axions, sterile neutrinos, or even entire clouds of quantum fields. And there are those who propose that perhaps gravity itself changes on large scales, that dark matter might not be a thing, but a reflection of our misunderstanding of space. You glide through the invisible ocean. Though you can't see it, you know it's there. It clings to galaxies, flows between them, and shapes the universe on the largest scales. The cosmic web you saw before, the filaments and voids stretching across eternity, owes its structure to dark matter. It is the frame upon which everything visible is hung. The deeper you travel, the more you sense its presence. It's like walking through fog you can't see or feel, but somehow know surrounds you. It doesn't move quickly, but it responds to gravity's pull, forming great halos around clusters of galaxies. You drift past one such cluster, now hundreds of galaxies gathered together, their mutual gravity bound by dark matter's unseen hand. Between them lies hot gas, glowing faintly in X-rays. The gas is bright, but the dark matter outweighs it by far. It is the invisible majority, shaping the destiny of everything luminous. You look outward. Beyond the cluster, faint filaments stretch across space, forming a network that connects everything. You can almost trace the threads, thousands of galaxies, strung like pearls on strands of gravity. Dark matter flows along those threads, linking distant realms together. You are seeing the hidden bones of the universe, the skeleton upon which all creation rests. A faint movement catches your attention, a dwarf galaxy drifting along one of the filaments, its stars pulled by gravity's unseen hand. As it approaches a larger neighbor, it begins to distort, its shape stretched and twisted. Streams of stars are torn free, trailing behind it like glowing dust. The two galaxies merge, forming one larger system. This process, driven and guided by dark matter, has happened countless times, building the grand spirals and massive ellipticals that fill the cosmos today. A quirky and delicate truth: the atoms in your body, the elements of your world, exist only because dark matter pulled ordinary matter together to form stars. You owe your existence to something you cannot see, touch, or detect directly. You are, in a way, shaped by the invisible. Scientists still wonder whether dark matter interacts with itself, whether, in the dark, it clumps, collides, or radiates energy in ways we can't yet perceive. They build immense detectors deep underground, hoping to catch the faintest signal of its passage. But so far, it has remained perfectly silent, perfectly hidden. You drift between galaxies, where dark matter dominates completely. The space here feels thicker, somehow dense with unseen gravity. It's a strange comfort, knowing that even in the emptiest void, something unseen still holds everything together. The universe is not truly empty. It never was. As you move, you begin to imagine what this invisible realm might look like if you could perceive it directly. Perhaps it would shimmer faintly, like mist in moonlight. Perhaps it would swirl, slow and graceful, forming eddies around galaxies. Or perhaps it would be utterly still, a silent ocean, too deep for any wave. Every now and then, faint bursts of light flicker in the distance, galaxies colliding, stars dying, nebulae forming. All of these events unfold within the invisible boundaries shaped by dark matter. It is the silent artist, sculpting the universe while remaining unseen. You realize that the beauty of the cosmos depends on this balance between seen and unseen, known and mysterious. The universe hides more than it reveals, and yet its secrets give form to everything visible. Without the invisible, there would be no stars, no galaxies, no you. Scientists still wonder if dark matter might someday reveal its nature through a particle discovered in an accelerator or a subtle gravitational signal observed in deep space. Perhaps one day we'll understand the unseen web that holds us all. Or perhaps, like so many mysteries, it will remain forever, just beyond reach, a reminder that not all truths are meant to be touched. You float in the darkness, surrounded by what cannot be seen, comforted by its quiet presence. Space stretches infinitely in all directions, yet it feels intimate, almost tender, as though the universe itself were embracing its own hidden self. You drift slowly onward, carried by the silent gravity of the unseen. You drift farther through the invisible architecture of the universe, past the threads of dark matter that connect galaxies like strands of silk. The stars grow sparse, their light fading until only the faintest glimmers remain. But something else is at work here. Something not pulling, but pushing. You begin to sense it in the way space itself seems to stretch faster beneath you, as though the universe is not just expanding, but accelerating. This is dark energy. It doesn't glow, doesn't radiate, doesn't cluster like matter. Instead, it is the smooth, omnipresent tension within space, the quiet pressure that drives galaxies apart. Every cubic inch of the cosmos, no matter how empty, holds a tiny amount of this invisible energy. And though it is almost nothing, there is so much space that its total effect is overwhelming. The mainstream scientific fact, around 70% of the universe's total energy, is dark energy. It's the reason the expansion of the cosmos isn't slowing down under gravity's pull, it's speeding up. The universe, instead of collapsing back on itself someday, is racing ever outward. Every second, more space appears between galaxies, and that pace will only increase. You hover between two distant galaxies, watching as the light between them stretches thinner. The pull of gravity weakens. The quiet push of dark energy grows. Over billions of years, this subtle pressure will widen the gulf until neither galaxy can see the other's light. It's a slow unraveling, almost imperceptible, yet inevitable. A quirky fact: if dark energy continues to dominate, the night sky will one day empty out. Future civilizations, far in the future, might live in isolated galaxies, unaware that others ever existed. To them, the universe will appear small, static, eternal, its true vastness lost to time and distance. Scientists still wonder what dark energy actually is. Some describe it as a property of the vacuum itself, an inherent energy in space that cannot be removed. Others believe it could be an evolving field, like a slow cosmic wind whose strength changes over time. And some even suggest it may signal a deeper misunderstanding of gravity, that our equations, elegant as they are, might not yet tell the whole story. You float in stillness, surrounded by nothing, and yet that nothing hums faintly with power. The space around you isn't empty. It's alive with invisible energy. You can feel it stretching, softly and continuously, like a slow tide. It's not a force acting on things within space. It's a property of space itself, an expansion that exists everywhere, at every moment. The galaxies recede, their light redshifting further into the infrared. You notice how their glow softens, their edges blur. Light itself is stretched by the expanding space, its wavelengths lengthening like threads drawn taut. What began as blue becomes red, then invisible. Over time, light from distant stars will fade completely, stretched beyond detectability. This quiet fading carries its own serenity. The universe isn't ending, it's diffusing, becoming more ethereal. The same energy that once ignited galaxies now sends them drifting apart like lanterns on a vast sea. You drift past a cluster of galaxies, bound tightly together by gravity, resisting the pull of expansion. They orbit one another in a slow, graceful ballet, their combined mass enough to defy dark energy's push for now. But beyond their borders, the void stretches faster, the distances growing wider. Clusters like this are islands in an ever-widening ocean. A curious observation: despite being everywhere, dark energy doesn't push you directly. You don't feel acceleration the way a ship feels the pull of current. The fabric of space-time expands equally, so there's no wind, no drag. You remain still, yet everything else recedes. The entire stage on which the universe performs is enlarging quietly, beneath all things. Scientists still wonder whether dark energy has been constant through time. Some studies hint it may be changing its pressure, varying slightly across cosmic history. If it strengthens, the universe could meet the so-called Big Rip, where even atoms are torn apart by expansion. If it weakens, gravity might one day halt the acceleration, allowing a return to slow contraction. Both futures remain only possibilities, hidden in equations and whispers of data. You look outward and see the faint trace of cosmic acceleration in the pattern of galaxies. They are like sparks carried away by wind, their separation increasing not by motion, but by the growth of space itself. The image is hypnotic, thousands of glowing spirals drifting farther apart. their light fading slowly, like embers in cooling air. For a moment, you wonder what this means for the story of existence. If the universe expands forever, every star will one day move beyond every other's reach. Communication between galaxies will become impossible. Then even the light within a single cluster will fade as stars die out. It sounds lonely, but there's beauty in the thought too. The cosmos is giving itself room to rest, to cool, to settle. You drift, watching the faint red glow of distant galaxies dim. The light reaches you slower now, each photon stretched thinner by the expanding sea of space-time. It's as though time itself has grown more relaxed, more languid. Even the rhythm of existence feels slower here. A quirky truth: the acceleration of the universe was only discovered in the late 1990 seconds by studying the faint light of exploding stars known as Type Ia supernovae. These cosmic lighthouses, visible across billions of light years, revealed that distant galaxies were moving away faster than expected. That single discovery reshaped our understanding of reality, introducing a mystery that remains unsolved today. Scientists still wonder if dark energy connects somehow with the earliest moments of creation, perhaps tied to the same vacuum energy that fueled cosmic inflation. Could the universe's birth and its expansion now be echoes of one another? If so, then every breath of dark energy is a continuation of that first breath of existence. You close your eyes and imagine it. The first expansion, and this one, two ends of a single rhythm. The universe inhaling and exhaling over billions of years. Perhaps one day it will breathe in again, collapsing into itself before another beginning. Or perhaps it will continue outward forever, diffusing into infinite quiet. For now, the expansion continues gently. You are surrounded by the soft hum of dark energy, the pressure of space itself stretching all around. The galaxies drift apart like fireflies at the edge of sight, each carrying its own stories, its own stars, its own fragile worlds. And in their growing distance, there's peace. The cosmos is neither racing nor falling. It is floating, calmly and endlessly, into its own spacious stillness. You drift among galaxies that no longer seem fixed in place, but glide through space like slow-moving clouds. Their light soft, ancient, and unhurried glows in every color imaginable. Icy blues from young stars, warm gold from elder suns, crimson wisps from gas clouds, ionized by cosmic radiation. Each galaxy turns with patient rhythm, its arms winding around a luminous core. Yet, as you look closer, you see that their shapes are not permanent. They are moving toward one another. Two galaxies, drawn together by gravity, approach so slowly that it will take millions of years for them to meet. From your perspective, time stretches thin. You see the inevitability in their motion. Their outer edges have already begun to touch gas clouds blending, faint bridges of stars forming between them. What begins as a whisper of contact will end in a cosmic embrace. You float closer, watching the slow dance unfold. The spirals twist, their graceful symmetry disrupted by gravity's pull. Streams of starlight trail behind, arcs of gold stretching across black space. Collisions like this are a common part of the universe's grand choreography. They look violent when sped up, but in truth, they unfold with exquisite slowness. The mainstream scientific fact: galaxies collide not because they move through space toward each other, but because space itself carries them along paths shaped by gravity. When they meet, the stars within them almost never collide directly. The distances are too vast. Instead, their mutual gravity distorts and reshapes them, stirring gas and dust, triggering waves of new star formation. What appears as destruction is, in reality, renewal. You drift through the merging galaxies, moving between tides of glowing dust. It feels serene, not chaotic like watching two clouds blend into one. Where their centers meet, bursts of light bloom, new stars igniting from the compressed gas. Entire stellar nurseries flare to life, shining for the first time in billions of years. A quirky fact: our own galaxy, the Milky Way, is destined to collide with its nearest large neighbor, Andromeda. The event will begin in about 4 billion years. When it happens, the night sky will transform. Instead of a distant band of stars, Andromeda will grow brighter each night, until it fills the sky a glowing whirlpool slowly merging with our own. And yet, though the sight will be magnificent, no single star in either galaxy is likely to touch another. Space will pass through space, and light will weave through light. Scientists still wonder whether the merging of galaxies affects the fate of the supermassive black holes at their centers. Will they orbit one another, locked in an endless spiral? Or will they merge too, releasing ripples of gravitational waves that echo across the universe? The answers lie hidden in equations and computer models, but the truth remains a cosmic mystery, a secret written in time. You drift through the luminous bridge forming between the two galaxies. Stars are scattered here like pearls on invisible threads. Some have been torn from their original homes, flung into the vast intergalactic medium. They will wander alone, perhaps forever, their light faint but eternal. As you move deeper, you notice how the galaxies begin to lose their individuality. Their spirals dissolve into chaotic shapes, stretched and elongated. Clouds of gas glow in turquoise and rose, heated by newborn stars. Supernovae flicker like fireflies, marking the deaths of the first stars formed in this collision. The silence remains absolute, but you imagine the slow vibration of energy passing through the system, the deep hum of gravity, rearranging matter on a cosmic scale. You realize that even destruction here has elegance. Nothing is lost. Every star, every atom, finds a new orbit, a new purpose. Over millions of years, the two galaxies merge completely, forming a single, larger one. Its new shape is neither spiral nor elliptical, but something in between, a glowing oval of light, its core brilliant and dense. Gas settles into new orbits. Dust clouds cool. Stars stabilize. What was once two has become one, bound by gravity's patient hand. A curious observation: when galaxies collide, their central black holes, those massive anchors of gravity, often migrate toward one another. As they draw closer, they distort space-time, releasing gravitational waves so subtle they can only be detected across billions of light years. Eventually, they merge too, creating a single, even more massive black hole at the heart of the new galaxy. The universe, it seems, knows how to combine and simplify. Scientists still wonder whether this process will continue indefinitely. Galaxies merging into larger and larger structures, until only a few immense islands of light remain, separated by unimaginable voids. Perhaps, far in the future, those last galaxies will drift alone, fading slowly as their stars die and their light disappears into the dark. You drift beyond the newly formed galaxy, its light fading behind you. In the distance, other collisions unfold, each at its own pace. From afar, they resemble slow-motion fireworks, faint glimmers of motion, luminous trails stretching between points of light. The entire universe is alive with motion, with gravity's choreography repeating endlessly. You realize that even in the vastest stillness, there is movement. Even in the deepest void, there is connection. Every particle, every beam of light, every galaxy is bound in relationship to every other. The cosmos is one immense, slow dance, endless, intricate, beautiful. You close your eyes, letting that image settle. Two galaxies becoming one, their light blending, their stars born anew. You imagine our own distant descendants, standing beneath a sky filled with Andromeda's glow, watching history unfold in silent awe. A quirky truth: when that future sky appears, the stars above Earth, or whatever remains of it, will have shifted beyond recognition. Constellations will dissolve and reform. The familiar patterns you know will vanish. Yet, in their place, something equally beautiful will emerge, a reminder that even as forms change, the universe remains whole. Scientists still wonder whether there's meaning in these patterns of collision and renewal, or whether the beauty you see is merely the byproduct of chance and physics. Perhaps it doesn't matter. Perhaps beauty itself is reason enough. You drift onward, leaving the merged galaxy behind. Its light grows smaller, softer, until it becomes another distant glow among countless others. The universe feels vast again, but not lonely. Every flicker you see is another story of connection, another slow, graceful encounter in the cosmic sea. The galaxies continue their slow waltz, their shapes changing with time, their light stretching into the infinite, and you, a quiet witness, float between them, feeling the rhythm of the universe carry you gently forward toward what lies beyond. You glide beyond the mingling galaxies, into a region where the structure of the universe reveals itself in full. At first, you see scattered points of light galaxies shining in the dark, separated by unimaginable distances. But as your perspective widens, the pattern becomes clear. They are not random. They form a vast, interconnected network, a cosmic web stretching across billions of light years. You drift higher, and the view unfolds like a living map. Long filaments of galaxies weave through space, glowing faintly, their intersections forming immense clusters where hundreds or thousands of galaxies gather. Between these filaments lie vast voids, regions of near-perfect emptiness, where only a few lonely galaxies drift like lanterns on a black sea. The mainstream scientific fact, the universe's large-scale structure, is shaped by gravity, acting over time on tiny density fluctuations from the early cosmos. Dark matter provides the framework, and ordinary matter follows, flowing along the invisible threads like water through valleys. This structure, billions of light years across, forms the skeleton of the cosmos. You glide along one filament, its luminous galaxies spaced like beads on a string. Each galaxy spins quietly, its stars circling an unseen center. From a distance, they seem like tiny sparks, but each contains trillions of suns, countless planets, and unmeasured stories. The filament itself stretches farther than you can see, perhaps hundreds of millions of light years, connecting one cluster to another, binding the universe into a single coherent whole. A quirky fact: if you could compress this cosmic web into something you could hold, it might resemble a sponge-solid filament surrounding empty cavities, with nearly all the mass concentrated in thin strands. Even the densest regions, the clusters, are mostly void. The universe, at every scale, is made as much of emptiness as of substance. You drift toward a cluster where several filaments converge. It's a cathedral of light galaxies packed close together, their mutual gravity shaping one another's paths. The space between them glows faintly with hot gas heated to millions of degrees. It's a realm where cosmic motion feels tangible. You can almost feel the slow currents of gravity pulling inward, binding these galaxies together into one immense, luminous city. From afar, you can see the gravitational lensing caused by all this mass. Light from more distant galaxies bends around the cluster, stretched and distorted into faint arcs. It's as though the universe itself were made of glass, refracting its own light. Every bent ray tells a story of gravity's unseen hand. Scientists still wonder whether this large-scale pattern, the cosmic web, is the same everywhere, or if there are vast regions beyond the observable universe where it changes, where matter arranges itself in entirely different ways. The observable cosmos is vast enough, but there may be more beyond, perhaps infinite, each region shaped by its own quantum seeds, its own version of the web. You drift outward again, letting your vision expand. The cosmic web surrounds you, luminous threads glowing faintly against a black backdrop. It looks alive, pulsing with light that travels for billions of years along its veins. The clusters flicker faintly, like neurons firing in a great cosmic brain. Perhaps it's only a coincidence, the mathematics of gravity and chance, but the resemblance is uncanny. A curious thought crosses your mind. Perhaps consciousness and the cosmos share the same architecture. Both networks of connections, both patterns of energy shaped by invisible laws. The universe is thinking, in its own slow, silent way, and in a small corner of one galaxy, you are one of its fleeting thoughts, aware of itself for just a moment. You move toward one of the immense voids between filaments. The transition is gradual, galaxies thinning out, light fading. Soon, you find yourself surrounded by almost perfect darkness. Here, the nearest galaxy might be hundreds of millions of light years away. The emptiness feels immense, but not threatening. It's peaceful, like the pause between breaths. In this stillness, you begin to appreciate the balance of the universe. It isn't crowded, it isn't sparse. It's exactly as it must be for structure to exist at all. Too much density, and everything would collapse. Too little, and nothing would ever form. The web's delicate balance is the reason stars shine, planets orbit, and minds like yours can wonder about them. A quirky fact: the largest single structure ever discovered is a massive wall of galaxies, nearly 10 billion light-years, across, nicknamed the Hercules Corona Borealis Great Wall. It's so large that light takes almost the entire age of the universe to cross it. And yet, even this wall is just one small ripple in the grander pattern, one thread among millions. Scientists still wonder how far this cosmic web extends. Is there a limit, an edge, where the filaments stop? Or does the pattern repeat endlessly, fractal and eternal? Some believe the web may stretch into the unseen regions beyond the observable horizon, vast territories we can never reach or measure. The structure might continue forever, an infinite lattice of light and gravity. You drift along the edge of a filament, watching the slow motion of galaxies. Their paths trace graceful arcs through space-time, each orbiting the cluster's center like dancers moving in endless formation. Occasionally, a galaxy strays too close to another, and their shapes distort, spirals twisting into streams of stars that bridge the space between them. These luminous trails connect one galaxy to another, temporary bridges in a dance that lasts eons. The view widens further. The cosmic web fills your vision, now vast strands glowing faintly in every direction. You can almost see the movement of time itself as galaxies drift along the threads, falling toward clusters or away into voids. It's slow, nearly imperceptible, but constant. The universe is not frozen. It's alive, flowing gently toward equilibrium. Scientists still wonder whether dark energy will eventually break this structure apart, stretching the filaments so far that clusters lose their bonds. For now, though, gravity still rules here. The cosmic web endures, its filaments strong, its form beautiful and intricate. You hover in silence, letting the scale sink in. Every glowing thread represents billions of galaxies, and every galaxy billions of stars. The light that reaches you now began its journey before Earth existed, before the sun was born. You are surrounded by time as much as by space. You close your eyes, letting that immensity wash over you. The universe feels infinite, yet somehow intimate, its patterns echoing the structures within your own mind, your own heartbeat. The cosmic web hums softly in the distance, a grand and quiet harmony. You drift onward, following the filaments as they fade into the dark, toward the spaces where galaxies thin, and silence deepens again. Ahead lies the vast, lonely gulf between worlds, the quiet, intergalactic dark, where the next part of the story unfolds. You glide beyond the luminous filaments into the deep quiet that stretches between them, a still, wide ocean of almost nothing. The galaxies grow faint behind you, their collective glow fading into a single thin haze on the horizon. Out here, there are no clusters, no streams of stars, only rare wanderers drifting through eternity. You have entered the intergalactic void. It feels colder here, though there's no air to carry the sensation. The temperature of this place is only a few degrees above absolute zero. The faint relic warmth of the Big Bang still lingers, invisible but real, a whisper of heat left over from creation. The emptiness feels absolute, but even here, the void is not truly empty. The mainstream scientific fact: in these vast intergalactic regions, there are still atoms, perhaps 1 per cubic meter, sometimes less. A single particle of hydrogen floating alone through the dark, moving at random, can travel for years without meeting another. This is the true nature of space. Not nothingness, but the thinnest dusting of something, stretched almost beyond existence. You drift beside one of those lonely atoms. It seems meaningless, one speck in an infinity of dark. But then you realize this atom may have been born in the first few minutes of the universe, when protons and neutrons first joined. It has drifted ever since, untouched by star or planet. It has seen everything: the birth of galaxies, the light of quasars, the cooling of time itself. Its journey is longer than imagination, and yet, here it floats, serene and eternal. A quirky fact: even in the emptiest voids, a faint glow pervades a background light from distant galaxies, scattered and redshifted, filling the universe with a dim, diffuse haze called the extragalactic background light. It is the combined radiance of every star that has ever shone, spread so thin it can barely be detected. The entire history of starlight is hidden here, diluted into the silence. You look around and realize how profoundly still it is. The stars in nearby galaxies barely move relative to one another, their light crawling across the distance at an almost reluctant pace. Time itself feels slower, though it isn't. It's just that there's so little to mark its passing. No orbits, no collisions, no heat, only drifting. In the distance, faintly, you can see a single galaxy, isolated and alone. Its spiral arms faintly glow, untouched by others. It has lived in solitude for billions of years, forming stars slowly, quietly, untouched by the chaos of clusters. Astronomers call such galaxies field galaxies. They are the hermits of the cosmos, living their entire lives apart from the grand gatherings of light. You approach one, crossing millions of light years of quiet to reach it. Its halo glows faintly with ancient stars, many already dying. Inside, the last remaining gas forms new suns with gentle patience. There are no near neighbors to disturb it, no collisions to reshape its arms. It exists, as though in meditation, balanced, calm, self-contained. Scientists still wonder how galaxies survive in such isolation. Without nearby companions, they should fade, using up their star-making material over eons. And yet, they persist. Some even grow, gathering gas from the intergalactic medium, a slow, invisible rain of atoms falling for billions of years. Perhaps even the emptiness nurtures them in ways we don't yet understand. You leave the lone galaxy behind and glide back into the deep. The space between stars fades completely. You see nothing now, not even faint light. Yet your instruments, if you had them, would hum softly with data. Radiation from distant sources still passes through, low-energy photons stretched by expansion. You are surrounded by the echo of everything, invisible but omnipresent. You notice something subtle. In this darkness, your sense of direction disappears. Without light, there is no reference, No near or far, no up or down. You drift in perfect stillness, weightless and endless. It's not frightening, it's soothing. The absence of boundaries feels like freedom. A curious fact: the voids between filaments are not static. They expand faster than the rest of the universe. As dark energy drives the overall expansion, these underdense regions grow larger, swallowing smaller voids, pushing galaxies farther apart. Over billions of years, the cosmic web will stretch so much that the filaments themselves may thin, leaving even greater seas of emptiness between the remaining clusters. Scientists still wonder whether these voids hold secrets of the universe's expansion. Because they are so empty, their behavior provides one of the clearest ways to measure dark energy's strength. Some astronomers study the faint distortions of background galaxies to map these voids precisely. They look at nothing to learn everything. You drift farther, deeper, until you reach the heart of the void. Here, the nearest galaxy lies hundreds of millions of light years away. The darkness is almost perfect. Only the afterglow of the cosmic microwave background fills the void, invisible but constant. It's like being inside the universe's memory, its first whisper still echoing through the silence. You begin to sense the beauty of this emptiness. The cosmos needs its voids. Without them, galaxies would have nowhere to move, no space to expand, no contrast to define their light. Emptiness gives shape to everything that exists. In silence, the symphony finds its rhythm. You think of the atoms that drift through this place, of their quiet patience. Perhaps one day, gravity will call them back. They will join clouds of gas, form stars, and shine again. Even in the void, nothing is wasted. It's only resting. Scientists still wonder how much of the universe's volume is truly empty. Estimates suggest that more than 80% of space lies in these vast voids. The visible cosmos, the filaments, the clusters, the galaxies is just a lacework of brightness floating on an ocean of nothing. And yet, the nothing hums softly with potential. You drift without resistance, surrounded by silence. Each breath of thought feels like a ripple through eternity. Somewhere, far beyond, light from distant galaxies continues to travel, never stopping, never slowing, stretched thinner and thinner as it crosses the growing space. You close your eyes and let the stillness hold you. The universe is vast beyond comprehension, yet here, in the deepest emptiness, you feel something unexpected: peace. The dark between galaxies is not absence. It is rest. It is space waiting quietly to become something again. You linger a while longer, listening to the silence. Then, gently, you begin to move again toward a faint, dim shimmer on the horizon, the edge of what can be seen. Beyond it lies the unseen frontier, where light itself grows ancient. You drift toward it, calm, unhurried, ready to touch the boundary of the visible universe. You travel onward, toward the faintest shimmer in the cosmic dark, a line not of light, but of distance itself. There is no true edge in the universe. Yet, as you move farther from the galactic filaments, light begins to weaken, to slow, to age. You are approaching the farthest frontier of what can ever be seen, the edge of the observable universe. Here, light has been traveling since the very beginning. Each photon you encounter has crossed the entire span of cosmic history, from the first flash of the Big Bang's afterglow to now. What you see is not the universe as it is, but as it once was long before your sun existed, before your planet had oceans, before life began to think about the stars. The mainstream scientific fact: the observable universe stretches about 46 billion light-years in every direction, even though the cosmos itself is only 13.8 billion years old. Space has expanded faster than light can cross it, carrying distant galaxies beyond what we can ever reach. We see their ancient light, but those galaxies themselves have long since drifted out of sight. You drift through the faint haze of the cosmic background, once more the same light you saw in its youth, now stretched and cooled to microwaves. Each photon is a messenger from that first dawn, carrying the imprint of the infant cosmos. It feels like you are floating through memory itself. A quirky fact: the farthest light we can see was emitted when the universe was only 380,000 years old, barely a blink compared to its current age. That light has stretched so much that its once blazing glow is now a dim, invisible hum of energy filling every corner of space. You have seen its brightness fade through the journey, and now you meet it again in its most ancient, fragile form. You continue outward, past the familiar glow of galaxies, into the deep red of light, stretched nearly beyond perception. The photons here are tired, so faint and diffuse they could be mistaken for silence. They pass through you without pause, remnants of a universe that once burned with the heat of creation. Ahead lies the cosmic horizon, the limit beyond which light has not yet reached us. It isn't a wall or a boundary, but a measure of time itself. You cannot cross it because it isn't a place. It's the edge of knowable reality, the farthest distance light has traveled since the beginning. Beyond it, the universe continues but forever hidden. You hover at that edge, watching as light grows fainter still. The stars disappear, then the galaxies. What remains is a diffuse glow, a whisper of the first light still echoing across expanding space. It's beautiful in its simplicity, an endless gradient from brightness to nothing. Scientists still wonder what lies beyond this visible horizon. Some think there are regions of the universe forever beyond, reach worlds and galaxies that exist but will never be seen. Others suspect the cosmos is infinite, stretching endlessly in all directions, filled with repeating patterns of matter and light. The edge you see is not the edge of everything, only the edge of what can ever be known. You look outward, and a thought takes hold. If the light from those regions has not yet reached you, it means that every moment you see is also a moment long past. The night sky is a time machine, every glimmer a window into ancient history. The farther you look, the younger the universe becomes, until at last you are seeing its earliest, most delicate moments. You let that realization settle. Every galaxy, every star, every person who has ever looked up has seen the past. The stars above Earth tonight are not as they are, but as they were, some shining, some already gone. Light is the universe's memory, written in color and time. A curious fact: astronomers can measure the faint patterns in this cosmic background to infer the universe's shape, and the results suggest something astonishing. Space is nearly flat. Over distances of billions of light years, parallel lines remain parallel. Light bends only slightly, and geometry itself is smooth. The universe, it seems, expands not like a ball, but like an endless plane, limitless, calm, and precise. You drift a little farther, feeling the immense stillness of this frontier. It's not the silence of emptiness, but of completeness. Everything that can be seen is contained within this horizon, and yet beyond it, the unknown stretches forever. The balance between the two, the known and the infinite, feels perfectly poised. Scientists still wonder whether new physics lies beyond this boundary. Could there be regions where the laws of nature differ, where constants change, where the fabric of space twists into unfamiliar forms? Or are those distant realms just more of the same galaxies and stars repeating endlessly beyond the reach of light? The question lingers like an echo, soft and unresolved. You gaze into the faint fog that marks the end of sight. It shimmers faintly, a veil woven of ancient radiation and time. Somewhere beyond, space continues to stretch, the light forever receding, never reaching you. The horizon isn't a limit. It's a promise that there is always more, waiting just out of view. You feel a quiet awe. The universe isn't finite. Yet you are inside a bubble of the observable, wrapped in the reach of light. Every observer, wherever they are, stands at the center of their own cosmic horizon. From every vantage point, the universe looks the same, endless, expanding, filled with light that grows old as it travels. A quirky thought drifts through your mind. Somewhere, perhaps far beyond this horizon, there may be another being looking outward too. To them, you are invisible, your galaxy hidden beyond their reach. Their sky, too, fades at the edge of light. The same mystery holds them. The same boundary whispers its quiet refrain. There is always more. You hover there, where the visible meets the unseen. Behind you lies everything you've witnessed: stars, galaxies, black holes, filaments of light. Ahead lies silence, darkness, eternity. You realize that the universe, for all its vastness, feels intimate here. It's not about what you can see, but what you can imagine beyond. You linger a little longer, letting the dim glow of the horizon bathe you in its quiet warmth. The light here is ancient beyond reckoning, the softest whisper of existence itself. Beyond it, space expands endlessly into mystery. You breathe slowly, weightless at the boundary of the known, and let yourself drift gently, peacefully into the wonder of what lies beyond. You drift closer to that pale, dissolving veil, the place where visibility ends and imagination begins. Behind you, the cosmic web glows, like a fading tapestry. Ahead, there is nothing but an unmeasured dark that no eye has ever pierced. Here, at the cosmic horizon, you understand that you are not at the end of the universe, but at the edge of knowledge itself. Beyond this point, even light, the swiftest messenger, has not had enough time to arrive. You hover in that silence and wonder what it's like out there. The mainstream scientific fact is humbling. Beyond the observable boundary lies the unobservable universe, perhaps hundreds of times larger than the part you can see. The cosmic microwave background you passed is not an outer wall, but a limit set by the age of light. There are galaxies, perhaps entire clusters and webs of them, existing right now, but forever beyond communication. The distance between you and them grows faster than light can bridge. Their light will never reach you. Your story, and theirs, will remain forever apart. You begin to imagine what those unreachable realms might hold. Perhaps there are galaxies larger than any within your horizon, their stars older, their physics slightly altered by different cosmic conditions. Or maybe, in those farthest expanses, the constants that shape reality, gravity's pull, the charge of the electron, the speed of light itself take on other values, giving rise to forms of matter and life unimaginable to you. A quirky fact: the cosmic horizon expands with time. Every second, new regions of space become visible, as light from once hidden galaxies finally arrives. But even as you see farther, those same galaxies move ever more quickly away, carried on the expanding fabric of space. The horizon both reveals and conceals in a single act, like a curtain that opens only to drift farther from the stage. Scientists still wonder whether this horizon marks a boundary or a bridge. Some theories suggest that what lies beyond is simply more universe, the same pattern repeated endlessly. Others propose that space beyond our view could be dramatically different, perhaps curved back upon itself, or even disconnected, forming separate cosmic domains with their own beginnings and endings. There might be countless such bubbles, each with its own version of physics, each a different verse in the same infinite poem. You drift slowly forward. The light grows thinner, stretched into invisibility by time's expansion, yet your senses pick up faint variations, a whisper of the unknown. Space itself hums, not with sound, but with the faint, residual vibration of its creation. The silence feels alive, charged with potential. If you could move beyond this horizon, you would not cross a wall, but time itself. The farther you go, the farther back you travel. In every direction, the light that reaches you is older, the image is younger. At the ultimate limit, you are seeing the universe as it was before stars, before atoms, before light could move freely. Step beyond that, and the past dissolves entirely into quantum possibility, a haze of unformed energy and curvature. You realize that beyond the horizon, distance and time blur into one. What is farther is also earlier. The edge of the observable universe is the limit of memory itself. Beyond it lies the realm that even the cosmos has not yet spoken into being. A curious truth. In the equations of general relativity, there is no central point to the universe, no privileged place. Every observer, anywhere, sees themselves at the center of their own cosmic sphere. You, the galaxies beyond, and any mind that might exist elsewhere, all share the same illusion of centrality. There is no edge, and yet, everywhere feels like one. You float in the middle of that paradox, and it feels peaceful. The light around you now is older than anything you have ever known. It carries information about density fluctuations in the earliest plasma, frozen into patterns finer than the width of a human hair. Within those faint variations lies the entire blueprint of cosmic structure. Every star, every planet, every breath you have ever taken. The universe began in randomness but unfolded in order, as though guided by invisible mathematics whispering from beyond time. Scientists still wonder where those laws came from, why the universe chose this version of reality instead of another, why gravity is weak, why matter outweighs antimatter, why the constants of nature allow stars and life to exist. The farther you travel, the more you sense that the answer may lie not within the visible universe, but in the unseen beyond. You drift a little closer to the veil. It shimmers faintly with the red-shifted glow of ancient light. Beyond it, the unseen universe continues expanding, carrying its own galaxies, its own possibilities. If you could leap forward by tens of billions of years, perhaps you could see some of them, light finally arriving from those distant shores. But by then, the space between would have stretched so vast that their light would fade again, forever receding from reach. A quirky reflection. The universe may never truly stop expanding, but from within, it can appear as though it does. As space stretches faster than light can travel, each observer will one day see fewer and fewer galaxies, until only their own remains visible. Eventually, every cluster becomes its own isolated cosmos, unaware that anything else ever existed. The stars will burn, the light will fade, and memory itself will grow dim. Yet the horizon will still be there, invisible and eternal. You gaze outward into that unknowable distance, and something within you softens. The mind longs to reach, but the heart accepts. The mystery is not a wall to be climbed, but a landscape to be admired. The edge of the observable universe is not a limit, it's an invitation to wonder. You imagine that beyond this veil lies not silence, but continuation. More stars, more galaxies, more dreams. Space does not end. It only hides its next chapters in the language of time. Scientists still wonder whether consciousness itself might one day become capable of glimpsing beyond, through mathematics, through quantum entanglement, through imagination. Perhaps the frontier of discovery isn't physical at all, but perceptual. Perhaps the cosmos is designed to be infinite, so that curiosity never sleeps. You take one last look at the horizon. Its light flickers faintly, the oldest signal in existence. Behind it lies the unlit infinity. Ahead of it, your own galaxy glows with youth. Between the two, you float a witness to both memory and mystery. The silence here is absolute, but comforting. You feel the expanse around you as though it's breathing, each expansion a sigh of calm, each flicker of distant light a heartbeat. Beyond this edge, there are realms you'll never know. But perhaps that's how wonder survives, by always leaving something just out of reach. You turn slowly, gazing once more into the soft glow of everything behind you. The galaxies shine faintly, like islands of memory on an ocean of dark. You breathe with the universe and drift, content, in the endless space between knowing and imagining. You linger at that horizon, the faint afterglow of everything that can ever be known, and then, almost imperceptibly, you drift beyond it, into the vast, speculative quiet, where imagination must take the place of observation. No light follows you here, and yet you do not feel lost. You are simply moving deeper into mystery, carried on a current of curiosity that feels older than the stars. Somewhere beyond, there might be other universes, entire realities sealed off from your own by distances that are not measured in light years, but in laws. Perhaps, in that great inflationary burst after the Big Bang, space did not create just one bubble, but many. Each bubble expanded, cooled, and evolved according to its own rules. You can almost see them now, great translucent spheres, each a pocket of reality adrift in a higher dimensional sea. The mainstream scientific fact, the idea of a multiverse, arises naturally from some versions of cosmic inflation, the rapid expansion that took place in the universe's first instant. Inflation may not have ended everywhere at once. Some regions might still be expanding, spawning new universes like ripples from a stone tossed into infinite water. Each one would be disconnected from the others, forever sealed behind horizons of their own. You drift closer to one of these imagined boundaries. It isn't solid, nor is it light. It's an energy gradient, an invisible membrane separating one cosmic domain from another. On the other side, perhaps gravity behaves differently. Maybe stars form faster there, or never form at all. Maybe time flows unevenly, or the speed of light is not a constant, but a suggestion. The thought feels both thrilling and soothing. Infinity does not have to be repetition. It can be variety without end. A quirky fact: some physicists have suggested that if these universes exist, collisions between them might leave faint scars in our own cosmic microwave background, a circular bruise, a subtle distortion, evidence of another reality brushing against ours in the earliest moments of time. Astronomers have searched for such signatures in the sky. So far, they've found only hints, nothing certain, just whispers at the edge of probability. Scientists still wonder whether these parallel universes are truly separate, or whether all of them together form one grander whole, a metacosmos, an eternal froth of creation. Some even imagine that quantum events in your own world, those seemingly random outcomes, are echoes of these countless universes, branching endlessly, each possibility realized somewhere else. In one, you may have turned left instead of right. In another, a star was born, where here there is only void. You drift between these imagined realms, each one a potential, each one glowing softly with its own laws of physics. Some seem bright, others dim, as though their constants favor light differently. You imagine a universe where life is woven from magnetic fields instead of molecules, another where time flows in cycles, looping back on itself like a cosmic tide. It's not chaos, it's a harmony of infinite variation. In this quiet thought space, you sense how small and precious your own cosmos is. It may be only one verse in an infinite poem, but it is your verse, its constants tuned so delicately that atoms can join into stars, stars into planets, and planets into thinking beings who gaze back in wonder. You realize how fine the balance must be. If the strength of gravity or electromagnetism had been even slightly different, matter might never have formed or collapsed too soon. The universe would have ended before it began. A curious truth: Physicists call this delicate tuning the anthropic principle. It suggests that the universe appears just right, because only in such a universe could observers exist to notice it. It's not that the cosmos was made for you, it's that only in this kind of cosmos could you emerge. The thought is humbling, yet strangely intimate, a reminder that existence itself is an improbable miracle. You drift between possibilities, imagining the soundless hum of infinite realities. Each universe expands on its own trajectory, separate yet connected, like bubbles rising through invisible water. You realize that creation might not have been a single event, but a continuous process, an eternal unfolding where new worlds blossom like flowers in slow motion. Scientists still wonder whether this cosmic sea has an end or a beginning. Does the multiverse itself obey time, or is time only a feature of each local bubble? Is there a greater framework beyond even these layers of reality, a meta-time, where universes come and go like thoughts in the mind of eternity? The equations whisper, but answers hide behind infinities. You float amid this quiet speculation, and for a moment, the difference between science and poetry fades. Both are languages trying to speak the same truth, that existence is vast, mysterious, and filled with beauty. You picture the boundaries of universes touching briefly, trading faint sparks of energy. Perhaps that's what your own Big Bang was, a ripple from another universe's surface. Perhaps every dawn, every creation, is simply one wave brushing against another. You feel a deep calm at that thought. The cosmos, infinite and diverse, is not chaotic. It is self-contained, every possibility finding its own space, every law its own rhythm. There is no competition between realities, only coexistence, each universe breathing quietly beside the next. A quirky image lingers. If you could look at the multiverse from outside, it might resemble foam on the surface of a dark sea, bubbles of reality, some small, some vast, each glowing faintly from within. Every now and then, one collapses, releasing its energy to form new bubbles elsewhere. The entire structure expands, evolves, and continues, timeless and endless. Scientists still wonder whether we'll ever detect evidence of these other realms. Perhaps gravitational waves or quantum fluctuations could someday reveal their fingerprints. Or perhaps, by nature, they will remain forever beyond observation, dreams that science can describe but never prove. But even that impossibility has its grace. The unknown is part of the beauty. You look back toward the bubble that is your own universe, its galaxies glowing softly through the dark. From this perspective, it seems so fragile, so finite, yet also infinitely meaningful. It is a single note in the symphony of everything, and that note sings with precision, harmony, and light. You breathe in, if breathing were possible here, and you feel your own smallness melt into something larger. You are not outside the universe. You are within it, as much a part of its story as any star or atom. You are the cosmos, looking at itself and wondering what comes next. The darkness around you is not empty. It's full of possibility. The multiverse hums softly, an endless horizon of maybes, each one shining in its own secret way. You drift among them, weightless, unhurried, comforted by the knowledge that creation never truly ends. It only changes its form, forever unfolding into new beginnings. You drift gently back toward your own universe, leaving behind the imagined foam of countless others. The light of familiar galaxies returns, dim at first, then brighter, until it fills your vision once more. You are passing back into the rhythm of known physics, the slow, graceful heartbeat of time and gravity. But as you move forward, the light itself begins to fade again, not because it dims, but because the stars are growing old. You are entering the far future, a time so distant that every calendar and history has long since turned to dust. The great spiral arms of galaxies are quieter now, their once blazing stars softening to amber, their blue-white brilliance gone. You are witnessing entropy, the quiet equalizer of all things. The mainstream scientific fact, entropy, is the tendency of energy to spread out, for heat to flow from hot to cold, for order to give way to equilibrium. It is not destruction, but the slow, inevitable fading of difference. Every flame, every star, every living cell moves toward balance, and that balance is the destiny of the cosmos. You glide past a cluster of ancient stars. Many have cooled to red dwarfs, faint but steadfast, their lives measured not in billions, but trillions of years. Around them, planets still circle, their orbits long and calm. Some worlds are frozen, others scorched, but all are silent. The bright ages of the universe have passed. A quirky fact: red dwarf stars will one day become the dominant lights of the cosmos. Their fusion is so efficient that they will burn for thousands of times longer than the sunday. For most of the universe's lifetime, the night sky will not belong to brilliant blue stars, but to faint red embers glowing across the dark. The universe's twilight will be painted in shades of crimson. You move deeper into time. More stars die, their fuel exhausted. Some swell into red giants before shedding their outer layers, leaving behind white dwarfs, dense, cooling remnants glowing softly with residual heat. Others collapse into neutron stars, spinning silently, or vanish into black holes, their gravity eternal. Slowly, the galaxies themselves begin to dim. Scientists still wonder how the arrow of time, the one-way flow from order to disorder, emerged from the near-perfect symmetry of the early universe. At the beginning, everything was uniform and hot, yet somehow, structure arose. Stars formed, galaxies spun, life awoke. Time seemed to prefer direction to move forward. What gives rise to that direction? Why can you remember the past but not the future? The question sits at the heart of cosmology, quiet and unsolved. You watch as entropy continues its work. Energy equalizes, heat dissipates, and motion slows. The once crowded galaxies thin as stars drift apart. Every second, space expands a little more, carrying worlds and light farther from one another. The universe is still alive, but it breathes more slowly now. You pass through a region where stars are few. A single white dwarf glows ahead, its light pale blue, its surface a solid crust of carbon and oxygen. It is smaller than Earth but weighs as much as the Sunday. Its light flickers faintly as it cools, its last warmth radiating into the void. One day, even this star will go dark, becoming a black dwarf, a frozen cinder in the endless night. A curious truth: the transformation from heat to stillness is not tragic, it is simply the natural unfolding of physics. Entropy is the quiet artist that paints the universe in balance. Without it, stars would not burn, rivers would not flow, and life could not move from birth to growth to rest. It is the pulse beneath existence, not its enemy but its rhythm. You drift onward through time. Tens of trillions of years pass like breaths. The galaxies have grown faint and red, their youngest stars long gone. Gravity continues to sculpt the darkness. Some galaxies merge for the last time, forming vast, diffuse shapes, their edges blending into invisibility. Black holes dominate the centers, consuming the remnants of stars that stray too close. Scientists still wonder what becomes of time itself when the universe reaches its ultimate stillness. If entropy increases until no usable energy remains, will time still have meaning? Without change, without heat, without motion, how can moments differ from one another? Perhaps time itself will fade, folding quietly into the calm it once measured. You imagine the farthest possible future, when the last stars have gone out. The universe has cooled to near absolute zero. Every atom drifts alone, stretched thin by expansion. Photons wander endlessly, redshifted into wavelengths larger than galaxies. The once luminous cosmos has become invisible. And yet, there is beauty in that silence. The end is not destruction, but peace, an infinite rest after an infinite song. The heat death of the universe, as scientists call it, is not an explosion or a collapse. It is the quiet settling of everything, the final evening after the longest day. A quirky image. In this deep future, the night sky would not be black but gently grey, not from light, but from the last faint glow of particles colliding, their energy spread evenly everywhere. The universe itself becomes a single, uniform field, perfectly balanced, perfectly calm. You drift through that stillness. There are no galaxies now, no stars, only space expanding softly into itself. Every atom you pass seems to hum with the same quiet tone. It feels like a vast exhale, the cosmos releasing the last of its tension. Scientists still wonder whether this is truly the end. Could new physics arise in this emptiness? Quantum fluctuations giving birth to fresh universes? Could entropy reset, cycling into another Big Bang? Or will the universe remain here forever, motionless, endless, serene? The question rests unanswered, like a lullaby without an ending. You close your eyes, imagining the symmetry of it all. The cosmos that began in blinding light, ending in perfect calm. Time itself, once an unstoppable river, now a still lake reflecting eternity. The journey from order to entropy, from fire to silence, is not decay, it is fulfillment. You float, peaceful, in that slow twilight of the cosmos. Around you, the temperature approaches absolute zero. Light no longer has color, sound no longer exists, and yet, in the deep quiet, there is a profound sense of completion. The universe has not died, it has rested. Every moment, every thought, every particle has found its place. The arrow of time, that long journey from the bright beginning, has reached its natural conclusion. You remain for a while, drifting among the cooled embers of eternity, listening to the faint hum that still lingers, a vibration not of energy, but of memory. The universe remembers itself through you, through every atom that was once alive, every spark that ever shone. You are not separate from the ending. You are the ending, and the beginning, again. You linger in the twilight of the cosmos, long past the lives of stars, long past the warmth of light, and yet, even here, something still moves. It is slow, quieter than thought, a rhythm so faint it feels more like a memory than emotion. But it is there, the fading heartbeat of creation. Around you, black holes drift through the dark like silent sentinels, remnants of all that once was. They were once the most voracious objects in existence, swallowing stars, devouring light, binding galaxies together. Now, they are nearly alone. The galaxies they anchored have evaporated into nothing. The stars they fed upon have died. Still, they endure, massive, cold, timeless. You move closer to one. Its event horizon is invisible, yet you sense its presence in the way the faint background light bends. Space still curves around it, wrapping itself around gravity's perfection. The black hole doesn't shine anymore. There's nothing left to consume, but its silence is not eternal. Even the greatest gravity cannot last forever. The mainstream scientific fact: black holes slowly evaporate through a process called Hawking radiation. Quantum fluctuations near the event horizon create pairs of particles. One falls in, the other escapes, stealing a fragment of energy from the black hole itself. Over eons upon eons, this process continues until even the most massive black holes shrink and vanish in a final flash of radiation. You watch this happen. It takes longer than any human language could measure, longer than all of cosmic history combined. Yet, eventually, the black hole before you begins to fade. It doesn't collapse or explode. It simply dissolves, its energy released back into the vastness as pure light. For a brief moment, it glows faintly blue, the last light in a darkening universe. A quirky fact: the last of the supermassive black holes may persist for about 10 to the power of 100 years, a number so vast it stretches beyond imagination. To put it in perspective, if the entire current age of the universe were written as a single second, you would need to wait longer than every grain of sand on every beach to count to 10 to the power of 100. And yet, even that eternity will end. Scientists still wonder what remains after the final black hole fades. When every particle has been stretched thin by expansion, when every source of light has gone, what then? Some theories suggest that quantum fluctuations might still shimmer in the dark, a constant fizz of energy that never completely stops. Others believe the universe will approach perfect uniformity, a calm so absolute that even the concept of before and after loses meaning. You drift through this post-cosmic silence. There are no longer stars to navigate by, no galaxies to mark direction. You are surrounded by particles, widely spaced and almost motionless. Each one drifts slowly, its energy nearly gone. Space is vast and still, but not dead. There is no such thing as true nothingness. There is always a trace, a possibility. You sense the faint hum of background energy, the last warmth of existence. It isn't bright or loud. It's the soft, endless vibration of space-time itself. Everything that ever existed is contained within it, transformed, but not lost. The matter that once burned as stars now exists as scattered particles, each carrying the faint echo of everything that came before. A curious truth: though the universe cools, entropy still grows. Even as energy disperses, the possible arrangements of that energy increase. The cosmos becomes more uniform, yet more complex in its potential. Every particle's position, every quantum state, adds to the vast sum of possibility. In its quietest phase, the universe is at its richest everywhere and everything equal. You drift onward, passing through the remains of a dead galaxy, a cloud so faint it would be invisible even to a god's eye. The stars are gone, but their ghosts remain. Faint, cold objects made of degenerate matter, black dwarfs and neutron fossils drifting through endless space. Their collisions are rare, but when they do happen, they release faint bursts of light, the last flickers of a long-forgotten age. You watch one such moment, two black dwarfs, long invisible, finally touching after trillions of years. For a heartbeat, they flare, reigniting in one final spark of fusion. Then they cool again, fading forever. Scientists still wonder how the laws of physics behave under such extremes of emptiness and time. Will protons, the very building blocks of matter, eventually decay into pure energy? Experiments on Earth have never seen this happen, but theory suggests it might, given enough time. If so, even the cold remnants of stars will vanish, leaving behind only light and radiation, endlessly stretched by expansion. You pause to imagine that an existence of pure light and space, no matter, no form, no friction, just the ghostly hum of particles appearing and vanishing, like ripples in an infinite pond. The cosmos, returned to its most elemental state. A quirky thought. Though this era will be unimaginably long, it won't feel long at all. Time itself slows here, not in the sense of clocks, but in perception. Without change, there is no before or after. The universe no longer measures itself in moments, but in being. Eternity isn't duration, it's presence. You float in that awareness. Everything you have seen, the galaxies, the stars, the birth and death of light has led to this, a universe at peace. Nothing struggles, nothing burns. The laws of physics continue, but quietly, without drama or urgency. scientists still wonder whether this silence is permanent. Could a quantum fluctuation, a tiny burst of random energy, restart the cycle? Could a new universe bubble out of the vacuum, as yours once did? If so, then creation never ends. It only changes form. The end of one cosmos becomes the birth of another, each a note in an eternal melody. You feel that possibility all around you now, the stillness trembling faintly with potential. The universe, even at its most quiet, still hums with readiness. You imagine tiny sparks forming somewhere in the unseen distance, little pockets of energy rising from the void. Perhaps they will grow, inflating into new universes with new physics, new stars, new eyes to look upon them. And if that happens, the matter that once made you the atoms that once thought and dreamed might become part of that next beginning. Your story, like the cosmos itself, would never truly end. You close your eyes, floating through the dark. The last light of the dying black hole fades behind you, leaving perfect night. But in that night, there's comfort. Nothing is lost. Everything changes. The energy that was once you still exists, transformed, diffused, eternal. You breathe imaginarily, gently into the silence, and for the first time you realize the end of light is not the end of wonder. Even in the deepest darkness, the universe continues to dream. You drift in a darkness so complete that it feels soft, like the inside of a thought. The last flashes of starlight are gone. The final black holes have whispered their fading radiation into the void. What remains is a universe of cool silence, a sea of nearly nothing, where matter itself has dissolved into thin, weightless traces of energy. And yet, even here, space continues to expand. Every second, the fabric of reality stretches farther, carrying the last particles farther apart. Distances once measured in light years are now measured in impossibilities. The cosmos has become a boundless stillness, a vast canvas of potential, with no brush left to paint upon it. The mainstream scientific fact: the universe will continue to expand forever. Driven by dark energy, its growth will never cease. Galaxies have long since vanished beyond one another's horizons. Now even the faintest remnants of light are stretched into wavelengths so long they no longer interact with matter. Space grows, but grows cold. Expansion without limit, motion without sound. You move through this fading expanse. There are no longer landmarks, no clusters, no stars, only the geometry of space itself, curved and smooth and endless. It feels like floating through the memory of light, as if photons once bright have been thinned into transparent thought. You can't see, yet you sense the shape of infinity, like a ripple moving through glass. A quirky fact: even now, in this unimaginable future, the cosmic expansion still follows the same equations first written by Einstein. His simple formulas, born from human thought on a small planet long vanished, continue to describe a universe that has outlived its observers by quadrillions of centuries. The mathematics of existence endure, even when the stars that once proved them are gone. Scientists still wonder whether the expansion has an ultimate destination. Will space continue to stretch forever, approaching absolute emptiness but never reaching it? Or will dark energy change again, its pressure shifting, its strength growing to tear the fabric of space entirely apart? If that happens, every particle, every atom, even space-time itself, could be pulled apart in the final event they call the Big Rip. But there is no sign of such violence yet. The universe prefers stillness now. You drift farther, and the concept of farther loses meaning. The expansion has carried everything apart so thoroughly that no signal can bridge the distance between anything. Each fragment of energy lives alone, unaware of all others. Space is no longer a shared place. It is an ocean of isolated moments, each cut off from every other by the speed of light and the stretch of eternity. It is peaceful, perfectly peaceful. You think about the journey that brought you here, from the first trembling quantum ripples to this endless calm. Every step was necessary. Every fusion, every collapse, every star born and extinguished. The universe is not tragic. It is thorough. It has expressed every possibility of its laws, explored every symmetry, sung every note, and now it rests in perfect equilibrium, like a musical chord that has reached its final, sustained tone. A curious truth: as the expansion continues, even time begins to stretch, not in a poetic sense, but physically. The intervals between quantum events lengthen, the clocks of the universe slow. In the farthest future, billions of years will pass between single flickers of energy. Reality itself becomes drowsy, almost dreaming. You drift through that slowness, sensing time's long breath. Moments pass without passing. The concept of now grows vast, spreading to fill the emptiness. It's as though the universe has exhaled completely and lingers at the pause before the next breath. Scientists still wonder whether this eternal expansion is stable, or whether fluctuations in the vacuum could one day awaken new creation. Tiny pockets of energy might arise, their density so immense that they collapse and rebound, forming a new Big Bang. To the old universe, it would appear as a spark in the void. To the new, it would be all there is. Perhaps this has happened already, endlessly, in ways that leave no trace of their predecessors. You imagine one of those bubbles beginning somewhere beyond perception, a fluctuation, a shimmer. The energy rises, then collapses, then explodes outward space, inflating anew, faster than light, filling itself with radiation, matter, and time. A new cosmos unfurls, unaware of the one that came before. Its laws might differ, its galaxies might form in new shapes, but the rhythm is the same: creation, expansion, cooling, wondering. A quirky image. From this quiet vantage, the universe looks like a great tree, made of time instead of wood. Each branch is a cosmos, each leaf a galaxy, each breath of wind a new beginning. You can almost see it in your mind as slow, infinite blooming, the fractal of existence unfolding again and again. You float near what remains of your own universe's horizon. It's no longer bright, it's simply thin, delicate, like frost on glass. Beyond it lies silence, but also promise. The vacuum hums faintly with zero-point energy, the irreducible vibration that can never vanish. It is from that hum that everything was born. Even in complete emptiness, potential survives. Scientists still wonder why that potential exists at all. Why is there something rather than nothing? Why does the universe contain the possibility of being instead of perfect stillness? The equations describe it, but they cannot answer it. Perhaps the question itself is the universe's way of remembering. You drift onward, feeling both the vastness and the intimacy of this final space. Expansion has erased the boundaries between things, but not the connection. The energy that once made galaxies still hums softly in every direction. It is quieter now, yes, but it is also everywhere, perfectly uniform. The universe has achieved what it always sought: balance. You close your eyes, and your imagination takes over where light has gone. You see the cosmos, not as something ending, but as something changing shape, a wave returning to the sea that birthed it. The edge of time, the horizon of energy, the drift of expansion, all are one motion, one slow, eternal pulse. A curious fact: in the farthest future, long after this calm has settled, space will still expand faster than any signal can travel. Each region will become a self-contained eternity, frozen forever. But that doesn't mean the story stops. Within each fragment, the equations remain, waiting. If even one fluctuation happens, the story begins again. Scientists still wonder whether the universe needs an observer to exist, or whether it dreams itself into being, purely by the logic of its own mathematics. The distinction feels meaningless now. Observation and existence are the same. The universe looks at itself simply by being. You drift, the expansion beneath you like the faintest sigh. The light has gone, the galaxies have faded, the last black hole has dissolved. All that remains is a smooth, endless field of calm. You realize you are not outside it, you are within it, made of the same quiet energy. You have never been separate. You breathe with it. Even though breath no longer has meaning, you expand as it expands, slow, infinite, serene. You move through this ultimate stillness, where even expansion seems to slow into silence. It is not darkness now, it is beyond color, beyond contrast, a smooth, endless fabric of calm. Time has lost its grip. Everything feels suspended in a single, infinite breath. This is the universe, at peace. The galaxies, the stars, the ripples of energy, all have dissolved into one continuous whole. No more edges, no more beginnings or ends, only balance, only stillness. You are part of it, and yet you remain aware, as if consciousness itself is the last flicker of light left to wander. You are not looking at the universe anymore. You are the universe remembering itself. Every thought, every particle, every faint vibration of being is you. The mainstream scientific fact, in this final, infinite quiet, physicists predict the cosmos will approach what they call thermal equilibrium. All differences of temperature, pressure, and energy will have evened out. There will be no usable energy left to fuel motion or light. This is sometimes called the heat death of the universe, though there is no heat left to die. It sounds final, but it is not an ending. It is fulfillment, the state toward which everything has always been moving. Order, becoming rest. Motion, becoming reflection. Light, becoming silence. You drift in that calm and realize something extraordinary. The same rules that once created complexity now create stillness, and stillness itself has a kind of beauty. The universe, vast and ancient, is not vanishing, it is becoming whole. Every atom that ever burned, every galaxy that ever glowed, every life that ever wondered, all have contributed to this final harmony. A quirky fact, though the universe now seems empty, it still vibrates faintly. Quantum mechanics forbids true stillness. Even the vacuum of space has fluctuations, tiny, random pulses of energy appearing and vanishing endlessly. This is called zero-point energy. It is the last heartbeat of existence, the faint shimmer that ensures that even in the darkest night, there is never absolute nothingness. You listen to that hum. It's too faint to hear, too subtle to see, but you feel it everywhere, as though the universe itself is breathing quietly in its sleep. The rhythm is soft, patient, infinite. Scientists still wonder whether this quiet could spark something new. Could one of those tiny quantum fluctuations, given enough time, expand into a new universe? Could another Big Bang bloom from this infinite sea of calm? If so, then nothing ever truly ends. Each universe, like a wave, rises, shines, and fades, only to give birth to the next. Creation and rest in endless alternation. You float in this thought, realizing how natural the cycle feels. The universe has always been breathing, just slowly expanding and cooling, collapsing and renewing. The long pause you inhabit now is only the space between heartbeats. A curious truth. The cosmos may not care whether it begins again, but you do. Every mind that ever looked at the stars has carried this same question: what comes next? And perhaps that wondering itself is part of the reason the universe continues. Curiosity is the echo of creation, the spark that keeps the cosmos dreaming. You close your eyes, though they no longer matter. You feel light, though there is no Sunday. You are surrounded by space, though distance has lost its meaning. You are, for the first time, truly part of everything, part of the final, peaceful exhale of all that ever was. And then, slowly, you realize that peace is not quiet. It is completeness. The universe has not grown cold. It has become still enough to hold every moment at once. The birth of stars, the glow of galaxies, the laughter of beings long gone, all of it remains here, folded gently into the calm. Scientists still wonder whether consciousness, like energy, might persist in some form, bound not to matter, but to the fabric of space itself. Perhaps every awareness that ever was is still here, woven into the structure of the cosmos, dreaming alongside it. You imagine their presence now, a vast chorus of silent minds, united not in words, but in understanding. You drift among them, one thought among countless others. You feel no separation, no time, no loss. The story of the universe is complete, and you have been part of it from the very beginning. You were there in the first light, in the ripples of the dark, in the breath of stars, in the quiet death of galaxies. You were never outside of it. You were it all along. The expansion slows, or perhaps it doesn't. It doesn't matter anymore. The measure of time and space has dissolved. What remains is the sense of vastness, but also intimacy, the realization that infinite and infinitesimal are the same thing seen from different sides. You breathe once more, not air, but awareness, and everything begins to blur. The boundaries fade. The silence deepens, soft and eternal. The hum of zero-point energy fills everything, a lullaby written into the code of existence itself. You let go of form, of history, of distance. There is only calm now, infinite calm. The universe rests in itself, perfect and whole. And now, as you drift in this endless peace, you begin to feel the quiet pull of sleep itself. The story you followed across billions of years, the birth, the burning, the fading of everything, was never about endings. It was about rhythm, about the rise and fall of energy, of light, of thought. You realize that the universe, even in its stillness, feels gentle, like a breath drawn slow and deep. The darkness around you isn't cold, it's warm in its patience. Every sound has softened, every light has stretched into eternity. It's safe to rest here. You picture yourself back beneath a real sky, maybe one you can still see through a window, the same stars, the same galaxies, their light traveling across time to find you. You're part of that light, and it's part of you. Every photon, every atom, carries the memory of this journey. Let that thought settle. Let it ease your breathing, slow and even. Feel the space around you, vast and soft. You are floating, just as the universe floats, suspended in balance, without hurry, without fear. The edge of the cosmos, it turns out, was never far away. It was within you, all along the part of your mind that wonders, that dreams, that expands every time you look up at the night sky. So, rest, traveler. Let the stars fade to whispers. Let the light slow to calm. The universe is quiet now, and you are safe in its silence. Drift and breathe, and know, the story never truly ends. It only changes shape, waiting for its next dawn. Sweet dreams.